Yeah, so very good evening to all. Today we have with us Lieutenant Colonel PJ Anand Kumar ji. He is an accomplished leader with over 2 decades of diverse experience in artificial intelligence, robotics, cybersecurity, and engineering. Colonel Anand is the founder and CEO of Critical AI Private Limited, and he is also CTO of DataVal Analytics, based in Bangalore, India. He is spearheaded advancements in NLP, predictive maintenance, HR analytics, agricultural yield prediction, and face recognition technologies. Colonel Anand previously served in various roles with the Indian Army, including as an AI and robotics program implementation officer, contributing to battlefield management systems, robotics, IoT, and cybersecurity initiatives. He also established cutting edge AI and robotics labs and worked on autonomous vehicles, swarm robotics, and managed systems. Notably, he has been the head of the Cybersecurity Research Center at Dayanand Sagar Academy of Technology and Management and a technical member of the National Cyber Safety and Security Standards. His career also includes pioneering work as a station engineer at India's Antarctic Research Facility, MAITRI, where he supported international scientific missions. Colonel Anand holds a master in electrical engineering from IIT Kanpur, a PG diploma in intellectual property rights, and PG diploma in international business from Symbiosis. And currently, he is pursuing his PhD in geoinformatics and holds a certification in various systems like digital forensics, network security, and deep learning. So today we have a visionary innovator and educator with us. Over to you, sir. Take a charge. Thank you.
Yeah, very good evening to all of you, and thank you, AIT, for giving me this opportunity, and thanks to Brigadier Bhatt sir for inviting me. Let me just share my screen and let's go over the presentation. So I'm not very sure if you had other sessions before, but 1.5 hours of session at 6 o'clock. So it's going to be a bit heavy, but I'll try to make it light. So it's more of a story form and more pictorial in nature. You can stop me at any juncture to ask any doubts. We will, of course, discuss various things towards the end as well, right? So today I'm going to be talking about use of technology and tactical battlefield. So if you look at tactics and strategy, so you can compare it to a chessboard, right? So in a chessboard, you have a goal where you have to get the other opponent's king. So that is the goal, and you may have a strategy of doing it. Probably you try to disrupt the defenses of your opponent and then try to infiltrate or try to deceive him. So you'll have various means of achieving the goal. And once you have a strategy, once you start playing, then you will be involving tactics into it. So you may have, you may use your horse as a tactical, move, and infiltrate the enemies or the opponent's defenses and things like that. So similar thing happens in the army as well. And we have strategies, we have goals, we have strategies, and then we have tactics, what you actually start implementing on ground to achieve the, to align with the strategy and to achieve the goals, right? But the issue is, like when you talk about technology, how the technology can be used for tactics, it's not a very straightforward answer which you can get, because the tactics have been evolving since ages, and it will continue to evolve. So the whole aim of the game is to deceive the enemy and try to win. So, for example, I'm from Corps of Engineers, and we actually deal with explosives, IEDs, improvised explosive devices, which is something like a booby trap, where it is actually created to deceive the person whom you're going to attack, right? So normally you'll find, like, we had an incident where we had this daisy chain of IEDs in JNK, where you had about 6 IEDs laid on the road as a chain. And when the bomb disposal team went there, so they started neutralizing these IEDs. So the first ID, second ID, and the third were almost similar. So when the person moved to the fourth ID, that had a different kind of initiation mechanism, and that killed that officer on that particular day. So what you actually find is, you find the enemy using some kind of tactics, some kind of IDs, and then it is trying to train you to get more comfortable, and the expectations are created, and then suddenly you will find a disruption in the fourth or the fifth attempt. So basically, it is a cat and mouse game of deception, where there will be deceptive layers coming up every now and then. So you really cannot prepare something for tactics, but definitely you can understand what tactics means, and understand what technologies are available, and try to use it in that particular time for that use case very specifically, right? So you can't have a standardized approach for to actually plug in technology to tactics. Even if you have the best of the technology, you may fail in tactics if you don't know how to apply for that particular use case. So that actually brings you to the art of using technology for tactics, rather than something which is templated, where you can actually learn and you can just replicate. So that's not possible. And also, if you actually look at what's happening today, there's plenty of technologies, and you can't use a particular technology and win a war. It's mostly all these gaps which are emerging are in the convergence space, where different types of technologies converge, and then gaps are created, and those gaps can be exploited by the enemy. So it's something like cybersecurity, where you have your own working environment, your security environment, which uses multiple technologies, which uses multiple people and processes. So you have the people, process, technology coming together, and creating new challenges, new gaps, and creating vulnerabilities. And when you actually overlay with the threat what the enemy has, what the environment has, the capability to actually attack you, then you will actually understand the risks in which you are operating, and you can reduce the risk by using the right technology, by countering it with the right technology. So that's a very what do you call, it's a game, and you got to have a game theoretic approach to actually using technology for tactics. So I just want to take you back to the evolution of the entire subject. If you actually look at armies, how they were fighting before, they were foot soldiers. Then you had horses, right? So you had the cavalry, and once you had weapons like rifles, then you could actually kill your enemy from a distance. So you had trench warfare, where you had people in line, and then they're firing at the enemy, and then they can actually neutralize them. But then you have disruptions like tanks, what the Nazis used to overrun France, right? France had, they had dug out the entire border, and they had placed their weapons and soldiers there. But that was not enough, because Germany came up with a strategy of blitzkrieg. And so it's a strategy come tactics, where they actually ran through these defenses in a lightning strike, and they could actually penetrate, and then they could actually capture the entire country with minimum damages, right? So that was, they could achieve the goal. So basically, these kind of revolution and military affairs is what disrupts your processes and your preparations. And today, with so much of technology and the way technology is progressing, these revolutions are coming quite often, and it comes up as a zero-day attack, right? So when you actually face the enemy, and that's when you suddenly realize that you've been compromised. You've seen how Hamas was compromised by the Israelis. They used the communication network itself, and they took down a lot of people. So basically, when we use technology, we are also allowing the enemy to come into us. And if you're creating networks, if you're using mobile phones, if you're using their data, if you're using AI models, so all of this can be a candidate where the enemy can utilize it against you as well. So we really need to evaluate all that and then take our decisions. And today, with the production cycle being reduced, you have formal methods where you really don't have to test extensively all your products. You can do the testing by using formal methods, and you can reduce the entire production cycle. Therefore, the disruptions are very, very fast. Also, it's multidimensional, multimodal, and the convergence of technology is creating its own challenges there. So if you look at how cellular organisms started, I mean, it's been a history of this disruptions and revolution, you can say. So from there, you started evolving a brain, right? So if you look at bees, they also have a occipital lobe. They have their eyes, and you have the neural network and the machine learning part, which is happening. So a bee can identify its prey, it can identify food, it can identify its mate, it can identify light and darkness and things like that. But it doesn't have the prefrontal cortex what the human being has, right? So therefore, you'll find a bee actually coming inside a room, and then it's trying to get out, and it's hitting the window panes, and it's not learning. It doesn't understand what's happening. It's got very limited capabilities, something like what our present day machine learning systems have, right? So they are prone to false positives, false negatives, and they and that is not a very robust system, right, to rely on. So even though we talk about the neural network, it was present in bees as well. Now we have human beings. So if you actually look at how things have been evolving, if you look at Neanderthals, they didn't have the ability to use logic, right? So they were mostly learning in a very linear fashion, something like evolutionary learning. And since they didn't have the prefrontal cortex, they couldn't use logic and they couldn't decipher things. But then Homo sapiens, they were weaker physically, but then they had their prefrontal cortex developed. They were actually improvising. They started using technology and they for their tactics and for their strategy as well. And they started tinkering, and that's when all the machines started coming up. You know, even cooking was invented by Homo sapiens, which actually reduced their time for hunting, time for eating. It made the entire process more efficient, and they had more time for growth as well. And therefore, you started having knowledge representations, knowledge sharing systems. Then you started developing formal scripts, portable knowledge, mass data. And then you started having these libraries and centers where you had information. But there was one major problem, right? So we had logic at that time. We had traditional logic. We had Indian logic, the Mayan logic, Egyptian logic, Chinese, so on and so forth. But then most of them were using premises which was not tested. Now, once they had the premises, they could actually combine those premises and they could actually deduce things. So that was working very well. So if you know modern logic, the validity part was taken care in traditional logic, but then the entire logic was not sound because the premises couldn't be tested. So there were plenty of different premises. So you that was the problem with traditional logic. And once you had centers like the Romans captured different civilizations and different countries and different regions, and they brought in the books and things like that. So there was conditions where uh, contradictions developed, and then they had to solve the contradictions. And once people started going, stepping out of the line, they had the clash of logic. So there was a problem with uh, the premises, and those could be explained. Like, for example, Galileo, he could actually create, he could validate those rationalism by using data, and it could be experienced, right? That's when people started really doubting every premises, and they started questioning all the premises, and that again was another problem. So when you had on one end the rationalism creating theorems, and then you had empirism. So these two have to match, right? So the modern logic brought in these two together, and it created a system of questioning the premises and then addressing the premises. So the premises had to be supported by data, and the premises had to be true. And then thereafter they use the validity part, which actually combines premises and creates theorems. And we have seen how things have evolved. I mean, the Britishers were the inventors of modern logic, you can say. And then you could always do thought experiments, and like you had E equals mc square. It didn't come from data, but it came from mixing premises using modern logic. So there were two processes. Like you have data. From data you can create premises, which is the inductive process, and you can use combine 2 3 premises and then do deductive logic and create theorems. So initially the deductive part was quite uh, useful, because we didn't have sensors, we were not collecting much of data. We were working more with premises, and then we had the theorem proving and the formal methods, those things developed. And but there was a problem with this method as well, right? The problem was using biased data. Now, Hitler used the same principle of data creating premises by manipulating the data and only taking out very biased data or a specific set of data to actually prove that the Germans had the Aryan race, and they were the superior human being, right? And that actually mobilized a lot of Germans and the country. And then we all know World War, uh, what kind of Holocaust and other things developed. So once the war was over, everybody took a look at this, modern logic again, and then they had to come up with a system of really fixing the premises from the data. So from the data, how can you actually create those premises which can be trusted, and where the scientific knowledge can be evolved further with those premises. And that's when we had this hypothesis testing. Most of you who have done PhDs would actually understand what it means. So basically in the hypothesis testing, when you say something, if you say the Germans are the superior species, then you have to take the null hypothesis, the opposite of that, and then try to get evidence for that. Now, if that evidence crosses 0.05 or 0.15%, then you dump that, because you have enough evidence on the contrary to contradict your hypothesis. So it's not very conclusive, right? Therefore, you cannot use that as a premises. And so this hypothesis testing solved a lot of problems, where you could actually prove that your premises doesn't have any counters, right? And you also had to publish it, and there were peer reviews as well, who could actually counter check. So if you look at how Volkswagen got into trouble in US, they had used biased data to prove that their emission norms were being met in US. Whereas one of the Indian only, I think it was an Indian researcher who actually got their data and started studying, and then he found that they were actually not meeting the norms, and they had actually used biased data to prove their hypothesis. And then Volkswagen had a huge issue, I think it was GM or Volkswagen. I mean, so they had to pull back all the vehicles, and they had to correct. So today, if you really claim something, you have to do the hypothesis testing. You have to publish it, and you have to get enough, and you should be open for criticism. So that actually makes the entire system robust, and that's a very foolproof system what we are using. Now, all this will come together when we actually use these things for tactics. You'll understand what is currently going on in our environment. Now, as we progressed on this, now with the modern logic, use of modern logic, and with data analytics, we really have the technology had taken off, and it's become very disruptive every now and then. There's an exponential rise of technology, and our property task environment is becoming more and more partially observed, stochastic, sequential, dynamic, and continuous, and multi-agent. So it's a very complex environment in which we are operating. And if you look at the industry, it's more the rules are very clear, and then you can apply RTI and things like that. But when you look at defense, everything is hush hush, right? So it's more of deception. It's more of not showing the picture to the other player, and it's not a very fair game. So the environment is very complex, and there's information overload. So when now you have too many sensors out there, and the main problem is to make sense of it. So today you can't just fight by with your emotions. You got to, and you're sort of kind of sticking out in this manner. So you evolved to fight emotionally, you evolved to respond emotionally, but then and intuitively. But then the environment has changed, and we are actually we can't carry on with our intuitions, but we need analytics. So to explain what's happening in our environment, military environment, where we have hundreds of sensors, we have the best satellite, the best cameras out there, and then we have good networking as well, right? So we have a lot of data. But then what happens is you need to collate all this and to understand. So what's the problem with that? So if you look at vision, now you actually collect information through the eyes, it goes into the occipital lobe, and then it sort of resolves. So you have the machine learning model there, and it can detect something, right? But then it can also have these kind of hallucinations. Similar thing happens with your machine learning algorithms as well, your LLMs as well, because it because just the machine learning part is not enough. So you need the reasoning and the inferencing engine as well to really understand that what you're looking at in this picture is not a face. But yes, you can recognize a face as well, but it's not a face because you can reason out, right? But let's say if you're drunk, you may not be reasoning out. It sort of switches off your prefrontal cortex. Maybe a small child where the prefrontal cortex not developed, again, it will not be able to make out the difference. And and so therefore, I mean, you got to create, or you got to develop something like the prefrontal cortex, which actually resolves this in your battlefield management systems, in your BSS systems, in your sensor networks, in the battlefield. So that's what is currently missing. And even if it's available with the US, or even the Chinese are much ahead in this. But we have to develop this. So this is something which is not available. If you look at cameras, you have cameras, AI cameras, which does the detection part, but then it becomes a nuisance. So for example, if you put a camera for elderly care, and if you're let's say this thing father is staying in India and the son is in US working. So if you put a camera, how will you make out the difference if the person is down on the ground? How will you know that whether he's having a heart attack or he's doing an exercise or yoga or something? Because both look similar. So current technology standards, these kind of activity classifications, it's still not mature, and therefore it throws out alert every now and then. There are false positives, and if imagine if that son keeps getting those kind of alerts there, instead of the father having a heart attack, the son will have a heart attack, because it's a big pain for somebody from US to come back here and respond, or look for someone to help him around where his father is living. These are very practical problems with AI cameras at present, because you don't have the contextual inferencing and the contextual reasoning along with it. Therefore, hallucinations, both in humans as well as machines, are happening, right? So these are again it's a static image, but it gives you a feeling that it's moving. The same thing happens with your hearing. So if you look at what kind of weapons US and Russians were actually developing, so in your ear, you can pick up certain frequencies. You can't pick up all the frequencies, though, right? And it also depends upon your age and your, if you have a cold and things like that, whatever. But you can develop a weapon which can throw out frequencies which is not audible to you through your ears, but it can be picked up by your body and your skeletal systems. And then there is cognitive dissonance in your mind, because so these kind of thing happens even in rooms where you have resonance frequencies and things like that, where you don't understand. You somehow feel that there is somebody else in that room and it's possessed and things like that. So this is the kind of effect what these weapons were creating. Like, you can just aim at a person and shoot that weapon, you'll not hear a thing, but then you will get frightened, right? Because of the cognitive dissonance. So you can create those kind of weapons as well. If you look at our human memory, yeah, it's not good. I mean, if you look at the training part of it, once you train, if you have an exam immediately, you will score well. If you have it after a long time, then you will be forgetting. So even memory is a problem. So you start storing information in either ICT platforms, and then learning is often happening without reasoning, because human beings, once they learn, they convert everything into heuristics, right? So this is what happens with ID neutralization. As you I mean, if you learn to neutralize 3 IDs, then the fourth one, you're going to be expecting the same thing, right? Your neural network is already getting trained, and you're not applying your reasoning anymore. The reasoning takes a backseat, and then the heuristic takes on, and that's a very dangerous situation. And that's where, and also added with the optimism bias, it's not a very good situation through which you can actually operate, especially in critical systems, when you're operating nuclear weapons, when you're operating, neutralizing IDs and radars and things like that. So you do have to overcome your biases. You have to overcome your training and think very disruptively. How do you keep an open mind? That's very important. So in a complex dynamics like this, right, you have something known as chaos. So what is chaos? So when you I mean, let's say this is an environment in which you're operating, and the same thing is applied in even machine learning as well. So in your optimization space, if you're at a particular spot and then you start moving down, right, or you're trying to reduce the cost function, you can land up in one place. But if you're very close to it and again start moving down, apply the same algorithm, you will land up in a very different place. So this is known as the butterfly effect also. So in a very complex environment, you have this chaos coming up and you have the butterfly effect actually happening. So what does that entail? It means that all your vulnerabilities also can be in the form of butterflies. A very small change in the environment or of tactics of the enemy can actually defeat you. At the same time, it also gives you opportunities. Even the opportunities are like butterflies. A very small this thing change, what you can do can defeat the enemy as well. So it's kind of the environment at which we are working right now is asymmetric. It is more favorable for the attacker because if he understands this vulnerability, he can really exploit. And this the same thing with the cyber security also. So you can just take your mind and sort of inductively think about cyber security, how it operates. The same thing is happening with a tactical environment uh, in the battlefield, because most of the activities are now started happening in the cyberspace as well. So what you really need to understand is in the battlefield, uh, you need a system which can evaluate. So if you look at what the CEO of OpenAI was asked a question that how will you use ChatGPT? How will you monetize? He says, I'm going to ask ChatGPT that because that's the right answer. I mean, you cannot really figure out with your biased mind, you cannot really figure out what you need to do. You have to have AI actually trying to decipher from this multidimensional space and tell you that this is exactly what you need to do in order to win this game, right? So in a chaotic environment, in a complex environment, according to game theory, chaos theory, you can't use brute force and win. You got to really understand where these butterflies are and then apply yourself. So therefore, your computational capabilities will be very, very important today, and that's where you find this chip war going on between the US and China, right? That's very, very important because if you look at what Chinese are capable of right now, they have 3 times more patents on quantum computing than US, and that's a very scary situation for the US. Though US has got a lot of technology behind them, and which is actually allowing them to dominate the space, but they are scared of Chinese because the way they are trajectory is moving up, the capabilities are moving up. So today the environment is not only even the battlefield uh, is actually connected with everything else. So it's a hybrid warfare situation, right? Where your economics, your politics, your relationships, international relationships, all these combine, and it's a very complex process when you actually look at foreign policies and how these things work. If you look at the supply chain, they are also very, very complex. They're kind of intertwined. So you really don't know where you can get trumped, how you can get trumped, and what you need to do in order to safeguard your own interests and defeat the enemy. So tactically, you can only do so much. You got to do a lot. Through your strategy, and also your entire roadmap has to be sort of sorted out. So today, if you look at all the problems which IDEX is throwing up, it's mostly coming up without all these analysis, right? It's just coming up from every corner. Every directorate is just throwing out what is possible, and then they're just trying to do that. And that's something like throwing ladders and trying to climb on top of it without properly arranging it up, without understanding what is the where your butterflies exactly reside and what you need to do. So essentially, even though we are making good progress in addressing our tactical requirements, at different parts, uh, it's not really not going to help us. So one example I would like to quote is, if you look at anti-drone systems, people are working on jammers and GPS spoofers and all that. So when we were actually developing drones in MCT, we had these problems. Every time the army commander would come to the site, the drones would crash. And later we found out that that was because of the jammer which comes along with him, and it was actually interfering with our control links and the telemetry links, and then it crashes. So we actually started working with autonomous drones without links. I mean, if it can just take the mission and then it goes on stealth mode, and then it operates and comes back. Obviously, you can always navigate using image or video analytics and also IMUs, and then you can really finish the mission. So these are the kind of drones which are going to come up in the future. DJI is already creating such kind of drones. But whereas what we are doing is we are trying to work on jammers, and we are putting a lot of money into it, and we will start buying this pan army and we will kit ourselves with it, but then it's not going to be useful any longer. The same thing happened with our ID bomb disposal teams as well. They had jammers which was not actually jamming the kind of spectrum what the enemy was using to initiate the system. And even if you have a jammer, you can always create a kind of mechanism where you can use the jammer itself and try to initiate the explosion. So a lot of things can happen there. So we need to be very, very careful about how we are going to what is going to help us and where we're going to put our money, right? So that's the idea. So today, with all that complexity, special forces are very important. You can't go in for a direct frontal attack. Stealth is important, anonymity is important, and analytics is very, very important, not an intuitive process. So the fog of war is really, really high with so much technology with us, and we really don't know what we are digging ourselves into till the time you really hit that space. So unless you analyze all this, you compute all this and try to evade, it's going to be difficult. So if you look at what kind of systems we are already using, so we are coming up with autonomous system for mine clearance, for explosive handling. So most of the systems, like because of the danger, were developed more for the sappers at present. Even if you look at Daksh, which is a robotic platform which is used for neutralizing IEDs. So all these robotic systems started coming up where you had these explosive issues. So I'll just skip all this. So you have robots now which can actually move into your pipelines, right? So it can also always carry explosives along with it. So you can use these robots also to, send a explosive device into a house. So you can see a lot of robots being used everywhere. You have these drones coming up. You have the robotic fighter planes coming up, which will have superior performance capabilities if you have a pilot inside it, because of the G forces, because of life support systems, because of the training and other part. It's not always. I mean, a plane aircraft which is piloted by a human being will not be able to withstand the kind of tactical maneuvers these aircrafts can do. The robotic planes. You have helicopters as well. You have this integration of human and machines coming up. And then how do you use whatever is at your disposal? You can use a dog, you can use a bee, you can always use fish. I mean, it all depends upon solving the problem, right? So the problem is, it's something like a black box. You have the initial state, and then you have the uh, final state. The final state has to really work, and you got to get the king. That's the goal. And in order to do that, how do you understand different systems, biological systems as well, and then incorporate them into your processes? Again, it's not possible to do it intuitively. You need computational devices for that. So what is possible, what is not possible? You can do a lot by using AI and computing it. So we were actually looking at this in MCT in 2011, 12, and we had systems like this. Of course, at that time, the significance of this was not very well known. Only after the Azerbaijan and Armenian war, people started looking at drones as a potential threat which could disrupt everything else. I mean, today you can have $1 million tank, but if you have a very cheap drone, it can destroy the tank, or it can destroy an aircraft, right? $1 billion aircraft. So all this was becoming evident to us when we started working with it. So we had the weapon mounted platform, we had IED handling platforms, we had platforms which could talk to each other. And so one benefit what you have with robotic platforms is you can always use the sensors of the other uh, robots around you, because these are all integrated. For human beings, like, you cannot actually connect one eye of a human being with another person's brain, right? But here in the robotic platform, you can easily do that, and they can work as a very close knit swarm of robot. You can connect your drones as well along with it, with the ground systems. You have remote presence. So these are all some of the things which we actually explored at that time. So if you see today, you have increasingly, robots being used in the battlefield. And again, command and control uh, is a problem. So like I said, you have the spoofing, and you have, you know uh, people trying to intercept your controls, and then they can take over the robot drone. So these kind of thing happened with the US, the Iranians. They actually hacked into the system and captured one of the US drones, and they started flying it the next day. So you have GPS spoofing as well, right? So there's electronic warfare issue which comes up when you start using so many drones, and you want to control it. So you will not be able to control it in every scenarios, in every place and location. You will have your own spectrum dominance at certain locations where you can trust your communication. So there you can open up, you can collect your missions. But essentially, when you actually start operating in enemy territory, then you can expect you jammers to operate there, and so you need to start operating in stealth mode there. And there, again, from a network centric warfare, you will have to get into the platform centric warfare, where you will have to have onboard intelligence and intelligence at the edge, which will actually allow you to function and carry out your tactical maneuvers and achieve your strategic aims. So if you don't analyze, and if you don't take the entire picture and do a multidimensional analysis, you will just be burning cash. So for example, like I said, I talked about this jammers, right? So the jammers will come. You will be spending a lot of money, but then it's not going to jam anything. It's going to be useless. So imagine a scenario where 50 drones come out of a vehicle, and then it just goes up near an airport, and it goes up and then looks down, and it can spot, identifies aircrafts, and just goes and rams it. It doesn't require GPS, it doesn't require controls, it doesn't require anything else. So it's going to be impossible for you to jam anything. But then these kind of jammers will be placed in all these airports. I don't know how it's going to really work, right? So 2 years from now, all this will be a waste of money unless you use the critical thinking loop, which is the inductive process and the deductive process together, right? Collect data and put it through deductive loop. Because today, if you look at battlefield, most of the data will be spoofed or fake data, because enemy doesn't want you to actually uh, collect data and start using it. So what we also do and what they also do, it's a strategic way of, the strategic forces are into it. And it's basically, you will even if you have the best camera up there, you have the satellite, you will be looking at a ship in a harbor, or a submarine in a harbor, and that may not be the real submarine, that be a dummy submarine, right? But you will find most of the activities taking place because the enemy goes to a great extent to spoof it, to make it appear that it's a real submarine and people are working on it and things like that. And so therefore, data alone cannot be uh, used for your purposes, for tactics. You need to actually understand that most of the data what you will be getting will be false or fake data. that is going to create a problem. So you'll have to use the deductive loop. That's very, very important. So the kind of systems we are working with, like you can say, first thing is collecting threat intelligence. So you have web scraping tools, you have SOCMint. The same thing happens with cyber. You have threat intelligence, and you need to collect information in real time. That's a big, big problem today, because how much can you serve and how many teams can you put there? Most of these guys who are supposed to be doing this are actually engaged somewhere else. So therefore, you need automated systems. And also there are issues with web scraping and collecting information and through OSINT, because as I said, there are spoof data, fake data, contradictory data. So even if you collect information about ID analytics, so we did all this and we have a platform called ID Map for ID analytics. So when you collect data from different news channels, some of them are talking about terrorism, some of them are talking about politics, some of them are talking about technology being used. And then the information which flows through these agencies are also in different timelines, right? So some of them will say there are 3 people dead, the others will say it's 5. So now you need to resolve these information which comes from different sources. And then you have to arrive at the right information. How do you sort out this? That itself is a very complex process where you got to use deductive systems. You got to use AI once you collect information from online sources, and then you need to store it in that manner, in a temporal manner. So maybe you say, okay, 3 guys died after this ID analytics in the first day, and after 3 days, 2 more guys died in the hospital. So you understand the contradiction is resolved in that manner. So you may have to also uh, quantify or understand which are the sources where you can which are reliable, and which will be reliable in a particular context, because the same source may not you may not rely on the same source in a different context, right? If so, it all depends upon who's actually peddling in this news. So that's a very complex process where we have to resolve. And then you have your graph analysis and other things, really trying to understand how one thing is connected with the others. And that these are some things which cannot be done intuitively, and it has to be done through a automated system with AI. So, so when you talk about ID analytics, so this is one of the system which we had created for core of engineers, where information is used to improve your operations, improve your procurement, improve your training, improve your HR, and improve your uh, distribution of equipment. So what happens is, like, we have, for example, if somebody's got alpha in a bomb disposal course in 2010, and somebody's got bravo in 2020, the bravo in 2020 will be better than the alpha in 2010, because after that there has been so much of changes, so many deceptive layers have been added, and the training is totally different, the kind of approach is totally different. So you need to actually cater all that uh, and understand all that when you actually deal with HR, because in the army HR was not functioning in that manner. It was more very, it was very static, and it's not dynamic, and it was not adaptive as well. So now with this system, we actually capture what the officer or the GC or Jawan is actually trained for, what is he learning. In case he misses out 1 week's training because he had malaria or he was admitted in the hospital, so we know his gaps. And when he is actually put it into action, we try to fill up those gaps. And when we look at I mean, when did he actually do the course, and after that what differences or what other layers have come up. So those again will become a learning gap for him, and we try to feed him with that, so that when he actually goes is deployed on the field, he is up to date and he's able to counter it, counter the, I mean, challenges in the best manner. So that's how we handle HR. Similar is with equipment. So when you actually come to know a particular kind of initiation mechanism, kind of spectrum which is used, where your the training at present and the neutralization techniques what you're using is not really covering that, your jammer is not really covering that, then you must be you must get your alerts, you must have these predictive ability that your equipment and your training will fail, and what you need to do in order to actually fill the gap. So that happens on the in real time, and we get the alert, and these alerts have to be sent from the EDD wing. So we did this for the EDD Center of Excellence, and this all this information had to be analyzed and had to be sent in real time to the CDUs, which are actually operating in the field. They are deployed in Northeast or in JNK and other places. So they need to actually learn from uh, experiences of others globally and try to prepare themselves. That has to happen in real time, which was not happening before. But using these kind of systems, we were able to push that through, and we were also it also throws out predictive uh, notifications and alerts for how do you do the budgeting, which areas are weaker depending on the HR, depending on the equipment and the training and the threats also, right? So where the risks are higher and risks are lower, how do you actually rationalize your equipment distribution? So all this comes up on the fly, and it also summarizes all the events once it does the online scrapping and brings in the information. It summarizes for the managers to actually understand it, so they don't have to really go and hunt for it. So it is kind of a push model. So it has also got a GIS integrated into it. So when you talk about surveillance systems, so we have our own platform called SentryFence. So basically, the surveillance at present, people have got a lot of cameras and they've placed it everywhere else. But it's very difficult to monitor, right? So when you actually look at, so there are various things which needs to be looked at. So you can use face recognition, you can use emotions, counts, people count, or the spatial awareness around equipment or a robot and things like that. And then you need multimodal AI analytics also to really understand and correlate and throw out notifications and alerts. But today, because people have just bought cameras and they have screens and they are actually viewing it in this fashion, right? The limited AI capabilities which are available, which actually triggers based on pixels and identification, is not really enough, because it doesn't allow you to do the contextual reasoning or inferencing, right? So what we have done is we have got our own uh, system. It's just a server with distributed system processing and also microservices, through which you can really set the context for each and every sensor and every camera. Or so it can be a drone, it can be a fire alarm system, it can be information coming from your RFID readers. So all of this is integrated in a PSIM system where you can correlate and you can do multimodal analysis, and that actually gives you the context, which throws out reduces false positives, right? So the access management as well is integrated along with the surveillance system. So these are some of the images from the field where we have deployed it. The drone and GIS mapping, so you can do the cartography and other things also, so that people in the control room really understand what they are actually looking at. These are some of the specs. So there are plenty of places where you don't have fences, you can't build fences, you have litigation land in the civil area, or when you talk about LOCs, you don't have fence everywhere. You can always put a virtual fence ahead of your fence and get a advance warning and alert. And so in LOC, the issue is with the range and the kind of resolution, high resolution images what you need to overlook the entire area, where a human eye cannot actually do the surveillance. You need, so people use binoculars, and then that actually gives you the zoom, but then it doesn't give you the context and uh, the entire view of the valley where it is actually fixed. So in order to actually use this, you need again AI. You need something like you need algorithms like satellite imagery. How you process satellite imagery, where you have to break it into tiles, you'll have to connect it together, and you'll have to read it, and then throw out alerts. So that's again a complex process. So we do our model building with the data for a specific camera as well, and specific locations, which actually improves the detection and reduces the false positives. So these are all in actual areas. So human eye is not able to actually detect, but AI systems can capture these. These are all in different settings where it's difficult for a human being. Even if you're looking at one single screen, you're just looking at a corner of it where something interesting is happening, but then you can miss out the actual tactical moves. So you can also remove false positives. So if you have statues like this, or because of the lighting conditions, you have something comes up as a face. So there are various means of inferencing. Again, the inference engine takes care of this and really understands that what you're looking at is a cloud and it's not a human face, and therefore you can reduce it. So we have other tactics as well to uh, you know filter out false positives. And you can also do obfuscations where your own troops and your own systems can be obfuscated in case it gets breached. You have other AR/VR solutions where, for example, the for AD weapon systems, for the missile operator, by the time he identifies an aircraft as friend and foe, or the most dangerous aircraft among a group of say 5 aircrafts, where few of them will have rockets underneath the belly and others may not. So in that case, it gets disrupted. I mean, uh, a human operator is not able to actually take the right call. You'll require cameras, and then you need to actually capture the signature, and that has to be automated. So this is something which we are also working on. And of course, you require the AI co-pilot and everything, which is the, I mean, these assistants are required to pull out information. You have multimodal AI and RAG brought into this AI co-pilot model. We're also into networks where you can spawn your own IBS networks, which are more faithful. I mean, these can be encrypted to your to the level at which you want, and you can have your own controls, and you can place your cyber controls there. So when you talk about immersiveness, now that actually will solve a lot of problem again in a BMS setting. Just give me a second. Can you hear me?
Yes, sir. We can hear you.
Okay, okay. I hope then there is not a lot of noise. Is it okay?
Yeah, yeah, that's fine.
Okay, okay. So talking about this thing, AR, VR, and mixed reality and metaverse, that is a very promising space where it is reducing your, uh, you know, uh, it can be used in various aspects. right from recruiting and training, planning, operation, and all that. Right now, uh, you have the Agniveers, right? They don't have much time, and they are not exposed to a lot of things because they have constraints of time and space. Because they have to churn them out very quickly, and they also have a problem of language, so they don't understand language. Uh, for example, in MEG Center in South, they speak Tamil and they can't understand Hindi. So they used to have a language class, and then they were exposed to different kind of bridges. They were exposed to different kind of equipment, which is not possible right now because of paucity of time. So therefore, we are developing AR VR systems, metaverse systems, where multiple people can come and practice their bridging and bomb disposal uh, processes and things like that, training. And so these can be used for operations. Also, it can be used for production. It can be used as an audit tool and for training as well. And we are also developing wargaming platform where multiple people from different cores and different arms can participate. So I'll just show you a video on that later. We have this digital twins of equipment, of terrain, of processes which can be used. And these platforms are intelligent, and you have the co-pilot actually helping you out. And also, uh, you have various units actually can come here and participate on the platform. And then you can integrate it with real 360-degree live feeds, annotate it. So this is a much easier way to familiarize with your terrain, which never used to happen in the actual. I think there's a lot of noise. Just a moment. Let me just sort this out. Yeah. So basically, area familiarization, post familiarization is also a big problem in the army for your tactical moves, and to understand the spatial terrain itself is a very important task. Where once an officer get posted and a new officer comes in his place, and he really takes some time to understand the terrain and post, and then you don't understand how it looks in different environment also, even if you go and personally see it, right? In So you don't understand, you don't know how what happens in that post after a snowfall happens, or when it starts melting, then what happens with the water, and how what kind of challenges those will throw. So all that can be captured in the AR/VR systems, and the day he lands up in the particular brigade, he can actually experience that, and he can make himself wise. And every time he can go to the post, he can understand the post in a different light, and it can be annotated as well. So I'll just show you those also on the video. So you can carry out GIS analytics and multimodal. I mean, all the analytics things will again come onto the metaverse platform as well. These are from our actual this thing. So let me just stop here and show you some videos. Okay, some of the systems which we are working on. So we're working on a 40 kg payload system for drones. So this uses Japanese technology. We have collaboration with a Japanese firm and also universities there. Now the software part and the UTM part that we are developing in India, where the workflows and others can be automated, and so this is a metaverse platform. Here, actually, I'm training another Jawan on how to use it. So you can see him
Sir,
moving here. Yeah,
sorry to interrupt you. Your screen is not visible.
you can't see the video.
No,
Okay, 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 okay.
just now it went.
No, okay. Could you see before?
Yes, it was there.
Okay. So let me just try it again. Can you see now?
No,
I think the share it came out of sharing, is it?
yes,
Just a moment.
I think so.
Okay, 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 okay. I think when I'm switching video, I think it is switching out. Just a moment.
Yeah, now
Now
your
you
screen
can
is visible.
now you can see,
Yes,
right?
everything is visible. Yeah, good.
Okay, okay. So this actually I'm helping out. I'm training another Jawan to spawn his posts. So this terrain which you see is recreated from data which was downloaded from Sentinel, from the European Space Agency satellites uh, data, and then it was recreated. So it's a digital twin, and then on top of it we have created this bridge. You'll see that towards the end, and right now this soldier is actually spawning whatever he wants. So you can get a vehicle, you can get a tent, you can get a tank, and you can drive that as well. Like all those functions can be created. So this is basically showcasing how you can deploy troops in your AR/VR platform. Multiple people can come and deploy their own this thing. So engineers can deploy their engineer equipment, artillery can deploy their artillery equipment. And then you can also fly over it and take a bird's eye view. And then there were other features as well as a POC. You can view a cartographic data on a platform. And you can annotate it. You can just go to that place. I mean, so you can build multiple application layers on top of this. You can also handle equipment. So you will have a bot which is actually telling you how to assemble it, how to remove it, how to troubleshoot. So all these. So this was just a POC, and you can have handle objects very realistically. So again, I think I'll have to. I don't know whether this will play. Can you see this video, or it's again stopped?
Yeah, it's visible.
Okay. So this is on a 360-degree image where you can annotate, and every post you can see where is the minefield, where is the border. I mean, generally you'll require a team of people actually explaining this to you from different directorates and different cores, depending upon their line of task. Whereas all this can be created and then they can use it whenever they want, depending upon the roles and depending upon its use. So similar things even for your equipment or control room or workshops, you have the same kind of. You can annotate, you can put 3D objects there and you can visualize. So these things are available even in Amazon, and you'll find these are all picking up everywhere. So the defense also needs to develop all this, which we are doing. So here it's the same. This thing, you can wear the headset and fly over the terrain. You can go to the city or location posts what you want. So this we actually developed for IWAI for the Ganges project, where the Prime Minister, the Chairman, and the Chief Minister can actually fly from different places. They can actually connect and they can have a joint tour together, and then they can descend on any of the projects which are happening, and those projects can be annotated, and it can have real 360-degree videos and things like that, which actually makes more sense of doing that. So this is the ID analytics platform. So this is a very old using version. We are working on the latest version now with the latest technology available. So this uses a GIS platform. So this GIS platform we had created specially for that with plugins. So here you can annotate the maps, and then you can publish it and send it to the teams which are operating in different places. It had predictive analytics tools also. So in a click of a button, you will come to know what you need to do, what is the budget, what is the next year's equipment list, what you need to procure, what should the training incorporate, depending on the threat intelligence, what you've achieved. So it throws all those gaps automatically, and the thing is, you don't have to do much. You don't have to do the analytics. It also has a knowledge base, something like a Wikipedia base, where you can click. And so the issue is right now, what we actually see is in most places there are decision makers, but all these decision makers are not operating from a common level of understanding of technology or process and things like that. So first we need to bring them together in a collaborative fashion, and for that you have to have the knowledge base also included into it. At every point the bot should actually teach you and should take you to the spot, give you sufficient information and evidence for taking your decisions. So it actually acts as a decision support system as well. So this is the way it'll just present all your uh, data from OSINT also, and gives you the complete picture and summarization of what's happening. So we are also coming up with our own AR glasses. Now this is under process right now. So this is the next version of the weapon mounted platform. And the robotics side, we are working with the Navy and on robotic board. So let me just take you back to the presentation. So for the Navy, we have at present the entire communication on land is on our platform in Western Naval Command. So it has been tested for the past 2 years. We've conducted the VAPT and tested everything. So it is going to get hosted on the Red Network, and 14 other centers are going to have this platform. So basically, whatever information comes from the submarine ships, they land upon our platform here. They come through the Bell systems and other systems, and then the decryption, and we look at the content and metadata and all that, and then we create our own signal packs. So the routing part of it, the managing part of it, everything is done by the AI system. And we also have to consider where the satellites are, where which direction the ship is moving, and where the antenna is on the ship, and depending on that take a call on which systems are the best systems. So such kind of optimizations, everything happens in real time. So we've replaced 150 people with just 5 right now, and they also had an audit team. Even that audit team is not required. So there are other problems also we are working on. So one of the problem which we have worked on is the AI's data analytics platform, where you have thousands of ships operating using AI's data and beacons, but you need a system, automated system, to really understand if a smuggling is taking place. Like you have two ships coming close to each other, they switch off the AIS and they are loitering in that place. So they go dark. So you come to know that there's something fishing happening, or you'll find a fishing boat actually in waters where there's no fish. So every naval boat it masquerades as a fishing vessel or a container vessel, and even the terrorists operate like that. Smugglers also operate like that. So from the way they are operating, from the way they are navigating, the moving, and from which port, so we have a algorithm which actually sorts out. So it's a ensemble method where it classifies the ship as a suspect, and it really tells you that this particular ship is not a container vessel, it is a naval ship. So you can classify uh, based on these AI algorithms. And there are plenty of other uh, problems also which we are working on. So most of them will involve cameras. Obviously, you need the cognitive part element of it. Right now, most of them are using machine learning only, without the reasoning part and without the inference engines. So we are developing those inference engines. That's our primary area of interest. So we are also developing state-of-the-art, joint control rooms or joint operational centers, uh, military police control rooms, and all those. So these are part of the R&D projects in which we are working. And when you talk about the cybersecurity, now everything, I mean, there's a lot of activity happening on the cyberspace, even with the armed forces and in the battlefield as well. So you really have to, I mean, most of the processes which you use for cybersecurity are getting applied to our processes in the battlefield and the tactics as well, right? So one needs to understand all the assets in the field, something similar to what we have in cybersecurity. And then we understand our own environment, our own processes, what level of training for the people. And so we understand our vulnerabilities. Apart from that, you got to understand what is the threat intelligence. So it's something like you are vulnerable to, getting the flu, but what is the environment? If the environment is pristine, then you're safe. But the environment, the threats are emerging and evolving, and those are growing, then you take a hit. So it's basically the combination of your vulnerabilities and your uh, the threat, how it's mushrooming. That's where the risk lies. So we understand the risks. We should uh, so what we do for the cybersecurity, we need to do for the battlefield. And then we got to evaluate the existing controls. How can you reduce your risks? How can you fill up your gaps in vulnerabilities? And how can you neutralize the threats which are emerging out? And then you got to understand the risk responses, and you got to actually automate those responses so that it's in real time, and you take in less damage. So very large amount of the SING effort which is involved will go into training, because most of the vulnerabilities are right now we are facing are with human angle, where you have social engineering and other issues. So I mean, that is a place where you need tabletop exercises for senior managers, and you need time to time notifications and alerts for the other employees, so that they can take necessary precautions. So we have partners like QNew is our partner. So Quantum Links and Quantum Secure systems can also be integrated. and we have AI co-pilots in most of the systems. It depends on the client. If they want it, we can easily integrate those as well. So with that, I think there is enough time for us to indulge in some question answers in case if you really want to explore certain topics, what I've spoken about, or you have some clarifications, I can do that. Hello.
Yes, sir.
Yeah.
Yeah. So participants, any questions? Yeah, Mangesh sir, go ahead. Just a minute. I'll change the settings. Yeah. So mics are allowed for all the participants. Mangesh sir, go ahead.
Hello, sir.
Yeah, we can hear you.
Hello.
Yes, you are
Yeah, I
audible.
can
Go
hear you.
ahead.
Go ahead.
Okay. Colonel Anand Kumar, this is a very informative session, I think.
Okay.
So I'm a little bit interested in the projects you have done by using virtual reality, AR VR.
Okay.
Because here
Okay.
in the AIT, I'm handling AR VR club as an in-charge faculty, and we are doing such small projects. So recently we are in the development of such project, which is a sand model. Digital sand model, which is
Okay.
used in the tactical trainings.
Okay.
So we are in the initial phase. So I have 2-3 questions regarding this, sir. Is it possible to create or develop terrain model of any geographical area only by using Google Earth images or satellite images?
Well, actually, the problem is the resolution and all that, what is required for your particular use case, right? So in battlefield management system, when we were developing, we had issues for the infantry. So the infantry wanted to know, where I want to understand where my right guy is and where my left guy is. Whereas the maps which we were having, the resolution was so low that the entire company was a dot, right? So it's very difficult to actually visualize that if your resolution of the data is very poor. So, so it depends on that. If you're looking at Air Force, then the maps are totally different, right? So they have a large, within seconds, they actually fly over the terrain. So, but if you're looking at infantry, then you got to have a very high resolution map there.
Okay.
And then the data
Okay,
also must be, I mean, without errors. Because if you download it from Google and all that, there are a lot of errors, and these errors are, and there are some of most of the data like where you're operating, those will not
Okay.
be available. Those are not published also. So, so it depends on what you're trying to build. As a POC, yes, you can use it, and you can show. But for actual production, I don't think it will work.
Sir, what data we can consider? We should consider for this development.
Well, if you're actually developing for some kind of a directorate or something, then they will help you out with their data. I think the
Okay.
best way is to link up with some this thing, get a sponsorer, and then you
Yeah.
can put your students there, because they may not send you the data. They can work
Okay.
with the data there. So that kind of
Okay.
this thing can be worked. In case if
Okay.
you want help, I think from the as a industry person, I can also kind of pitch in there.
Okay, sir. Okay, sir. Then I will be in the touch with you.
Mhm.
And sir, my second question is it possible to develop such projects in 3D or 360 VR applications only by using open source versions of Unity, Blender, or Maya?
Right now, I mean, we are all reliant on that only mostly, but we don't have our own OS, we don't have anything. So probably, I mean, you can do that, but you'll have to do it on premise, right? So
Okay.
you can have the data also on the headset itself. So you should not be using the cloud. That is
Okay.
the only constraint. Otherwise, you can deploy it in your own servers, and then you can work with it.
Okay. And sir, my last question, what is the role of geoinformatics in the development of such applications?
Pardon me, role of?
Geoinformatics.
Geoinformatics, is it?
Yes, yes.
GIS. Okay.
Yes,
So
yes, yes.
geoinformatics, everything on the spatial, this thing, obviously, you'll require the 3D maps, and then you'll require different tools to use, right? And if the tools are not there, you can always create a GIS plugin and create your own tools and use it. So definitely you will require the understanding of geoinformatics. You'll require a GIS platform to work on.
Okay.
Right, so that will have to be draped over the thing to have the real this thing, so that you're working on the real terrain. And whether you're working on spectrum analysis or you're working on logistics or engineering problems, you will have to have you'll have to use GIS. Yeah, those will be necessary.
Thank you so much.
Yeah.
Yeah. Any other questions from the participants? Those who are having questions, they can raise their hands.
So I have a question. In case participants don't have a question, what ails India? I mean, we have Indians going to US and working there and producing technologies, but in India somehow we are trailing behind, and we are mostly into demonstrations and things like that. We are not able to build anything substantial. What do you think is actually hindering us?
Yes. Any participants?
You can think about it and come back to me later also. You can text me or send me a mail. Depends.
Yeah. So
Because academicians, I mean, I find even from AIT and all that, most of them are working for foreign firms. Firstly, they are paying them well, but then even the mindset and this thing is different, so people are happy there. I don't know.
That's true. Okay, so it was nice discussion. On behalf of the Army Institute of Technology, I extend my heartfelt gratitude for delivering such a insightful session on the use of technology in the tactical battlefield, sir. Your extensive knowledge, the practical insights, and the way you deliver the session were truly inspiring and have broadened our understanding of how technology can be a game changer in a modern tactical scenarios. So the examples that you have given, the strategies you shared will undoubtedly have a lasting impact on how we approach our work and future challenges. So we deeply appreciate the time and effort you dedicated to this session and look forward to learning from your expertise again in the future as well. Thank you. Thank you very much, sir.
Yeah. Thank you all. Thank you all.
Participants, I'm sharing the attendance and feedback links in the WhatsApp group. Please fill those. And within 5 minutes, we are going to start the next session. I think it's 7:30. The next speaker is also ready. I'll check with him, and then within 5 minutes, we can have a second session. Okay. The feedback and attendance link are posted in the chat box. Please fill them. I'll check with the second speaker. I'll get back to you in 2 to 3 minutes.
Warhali.
Yeah, good evening, Dr. Ashwani Kumar. Can you hear me? Dr. Ashwani? Yeah.
Good evening.
Good
Am I
evening,
audible?
sir. Yeah, you are audible, sir.
Okay. Okay.
Yeah, so all the participants are ready. Let me introduce you first and then you can take the charge.
Okay.
Yeah, so we are starting the second session of the day. And today we have with us Dr. Ashwani Kumar. He joined DLRL Hyderabad in 1984 as Scientist B. And since then, he has been in the field of research, design, and development, and its productionization of various types of state-of-art wideband antennas, antenna systems, components, and radomes for communication and radar electronic warfare applications, which actually covering HF to millimeter wave frequency band. He has worked in the various capacities for prestigious defense projects and programs. As a project director, he has vast experience in leading and guiding team of scientists and technical staff. His indigenously design and develop antennas, components, and antenna systems have made the country self-reliant in this critical technology area. The antennas have been productionized on TOT through various PSUs such as Bell, ECIL, Cell, and other private agencies in large quantities. So these antennas are integrated on various land vehicles, ships, submarines, aircrafts, and satellites for defense services and SI directorates. His present area of interest includes multi-beam phase array systems, shared aperture antenna systems, cognitive EW systems, and wideband printed circuit antennas for satellite navigation. Dr. Ashwini Kumar has 4 patents on his name, 21 technical reports to his credit, and has published more than 40 research papers in SCI journals, presented international and national conferences. He has delivered more than 35 expert guest lectures and invited talks. Dr. Ashwini Kumar has guided several MTech and BTech students for their projects, also has been examiner for various PhD theses. After superannuation in June 2019, Dr. Ashwini Kumar has been regularly conducting online classes for various institutes for MTech on tactical battlefield and communication warfare. So today we have a guy who has a very vast experience in both the fields. So welcome, sir, and I request you to take the charge. Thank you.
Thank you, Dr. Rane. Good evening to all the participants. It's my pleasure to share with you all some of my experiences and my work as well, and to take you into a technology area which is not very much liked by many of the engineering students or science students. This area, when I joined, people used to tell me that it's a very dry area. Why you are interested? But somehow I got interested into it and start enjoying my work. Slowly, I found that this technology required a lot of efforts to have at least the command for the country to develop antennas which are in general denied to for import from other countries. Now, these antennas, I'm going to talk about antenna technology, is it is a general, most general. I will try to present it in a very what you say, layman's language, which even the person who is not in this field, associated with this field, he will be able to understand. Now, antenna is, it is very important component of any electronic system. Even if you see your TV, the TV has got antenna which receives the signal, and then you have got receiver and display which displays the signal. There are other.
Sorry to interrupt you, sir. Are you sharing your screen?
Yeah, I will share. This is just introduction.
Achha. Okay. Yep.
Okay, so I will share the screen. The screen is visible?
No, sir, not yet.
Not yet?
No, sir.
1 minute.
So on Teams, on the right hand corner, you can see the share button, and you can
share.
either share the complete screen or you can share the window.
Is it visible? No.
No, sir, not visible. Once it will be shared now, it will be a red border area. So is your presentation open right now?
Yeah, it is open now.
Okay, so just click on share button. What you are looking at? Can you see screen and window option? Once you hit the share button.
Yeah, I'm seeing the Chrome tab, window, and entire screen.
Acha, so just click on entire screen. The entire screen will get shared.
Okay. I should not minimize my.
Yeah, so that's the thing. If you are sharing a complete screen, otherwise, what you can do, you can just open your presentation and make it in presentation mode, and then try to share it again. So in Windows section again, like Chrome, you will be able to see the presentation as well.
I think. One minute.
Yes, sir.
Just a minute. Huh?
Sir. Yeah, now it's visible, sir. Just make it presentation mode. Yeah, you are muted. Just unmute yourself and then you can start. It went off again. You need to share it again.
Yeah. I think now it is okay.
Yes, it's visible.
Okay. Okay. Let me start. Sorry for your some technical problem was there.
That's fine, sir.
Yeah.
That's fine.
Okay. Let us go ahead. Now,
Yes.
as I was telling you that the antenna is, you can say, the sense organ for any electronic system. So I gave an example of your TV. You must have seen the antennas changing the shapes, size from the previous earlier days till now. now you find even in your mobile phone, there is an antenna which is not visible, but which is embedded inside the chip as well. So I will be discussing, if I'm discussing the antenna, means the antenna, this antenna is a general topic on, it can be used for any application, maybe ground base, on ship or aircrafts, on satellites, in space also. There are numerous use of these antennas. I will be more discussing about the electronic warfare antennas and antennas for satellite navigation. My talk will be within these limits.
Sir, sorry to interrupt you.
Yeah.
Your slides are not changing.
Not changing. It has changed or not?
No, sir.
No?
No, sir.
Sorry.
So I think your presentation mode is not get shared. Right now we can see the normal presentation. You can just, yeah, you can utilize that also. That is also fine. We can see your presentation. It's clear. Now we
Okay.
can see the change. Yes, sir. Yes, sir. Go ahead.
Okay. So my talk will be bound within these limits. That is the antenna fundamentals for people who are not familiar with the antenna things. So to make them understand whatever I talk further. Then an introduction to electronic warfare, what it is, so that you can appreciate why these antennas are so different and why they are required in the electronic warfare. For in electronic warfare, the antennas are for signal detection, direction finding, then and jamming applications. So these are the main sections of the electronic warfare where different types of antennas are used depending upon the requirement. Then I will briefly tell you about satellite navigation concept, then different types of antennas being used in satellite navigation. Antenna technology is not alone. It has got uh, to work with a radome, because antennas are components and they are open to environments. So radomes are basically radar dome. From there, this acronym has come, radome, which gives a dome or a cover over the antenna, which is transparent to electromagnetic radiation, but it protects the antenna from environmental changes, because antennas are in general made of metals. So there are chances that antenna may get corroded and its life gets reduced. Then, if time permits, I will discuss about trends in antenna technology which are going in the world. So, antenna fundamentals. Now the slides are changing.
No, sir. From the left panel, you need to change.
Okay.
Now they are changing.
Now they are changing.
Yes.
So why it is not going in presentation mode? Anyway, I will slightly increase its size so that
Yes, we can see it is
you can
better
see
shape.
it.
It is in, yeah,
Huh?
it is in better shape. Yes, sir.
Yeah. So the definition of an antenna is, it is a device to radiate or receive radio waves. So we are dealing with radio waves because antenna is the which intercepts the electromagnetic waves or radio waves, or it transmits the electromagnetic waves or radio waves, because all radio waves are electromagnetic wave radiations. So a device which can radiate or receive radio waves is known as antenna. An ideal antenna radiates all the power delivered to it in desired direction or directions and with desired polarization. So, of course, in practical, no antenna is like that, because some power loss will be there because of the mismatching of the impedances, because of the metal loss, because of the radiation loss. There are so many losses are associated with it, but an ideal antenna will radiate all power which is delivered to it, and in a desired direction. It should radiate in desired direction with desired polarization, so that the electromagnetic waves have got two types of polarization: horizontal polarization and vertical polarization, or it depends upon a combination of these two. Some of the terms which I will be discussing in the antenna field, that is radiation pattern. I will explain each term in brief. Radiation pattern, beam width, side lobe level, back lobe level, polarization, and gain. The radiation pattern is the graphical representation of relative amplitude received by the antenna at a constant distance from transmitting antenna over 360 degree. It means that an antenna, it will receive the signal from all the direction, 360 degree, over 360 degree, or from a sphere in a three-dimensional picture if you take. Now, whatever the energy it receives at different angles, different points over the rotation of 360 degree at a fixed distance from the transmitting signal, that will give you the presentation of a radiation pattern. Now, I will show you the radiation pattern, which looks like this. This is the radiation pattern if it is plotted in relative intensity and the angle. That is, this is 0 degree minus 180 degree plus 180 degree. So if you take a two-dimensional plot, it will look like this. If you take a three-dimensional plot, it will look like a balloon with some small fringes here. Now, the antenna is characterized by its beam width. That is, beam width is the angular width of the major lobe of antenna radiation pattern. Now, the bigger lobe, this is known as major lobe, and the lobes which are on the side, they are known as side lobes, and the lobe which is at the opposite to 0 degree, that is 180 degree, that is known as back lobe. So the power of the antenna being received, 50% of it is known as half power beam width, that is 3 dB beam width, means the power reduces by half. At that point, the angle which is between this point and this point will give you the beam width. So this is the angular width of the major lobe of antenna radiation pattern. A side lobe are the minor lobes adjacent to the major lobes. These are side lobes. It is expressed in relative side lobe level. That is, if this is, say, 0 dB, then this may be about 30 dB down. So minus 30 dB side lobe, like that. If its peak is level of the highest side lobe relative to the peak level to the main side lobe. That is, this is the level of the lobe, which is 30 dB down from this point. Now the term comes polarization. Polarization of an antenna is the orientation of the electric vector. In electromagnetic, the electric vector is the prominent component which we consider for all the applications. Now, this electric vector, if it is linear, and if it is horizontal to the Earth's surface, because Earth's surface is taken as a reference, if it is horizontal to Earth's surface, it is known as horizontal polarization, and if it is vertical to it is known as vertical polarization. Now, there are other types of polarization which is a combination of these two polarizations, horizontal linear polarization. The general polarization is elliptical polarization. In elliptical polarization, there are two orthogonal field components with some phase difference. Means it has got a field component along this axis, but it has got certain phase difference between the two. So it will give you a shape of the ellipse if you join them. If magnitude of the orthogonal field components are equal and have 90-degree phase difference between them, then if the magnitude is equal, and here it is not equal, if it is equal and has 90-degree phase difference, then it gives you circular polation. Now there are two types of circular polation. Clockwise, that is right hand circular polation, and anti-clockwise, that is left hand circular polation. Now this polation concept is very, very important for designing any antenna and for which system it is being designed. Somewhere you require linear polation, somewhere you require circular polation, depending upon the requirement. Now, circular polation, if you hold your right hand and if you fold your four fingers and hold your right hand, if the direction of your thumb shows the direction of propagation, then the curved fingers will tell you whether if it is matches with the right hand, then it is known as right hand circular polation. If it matches with the left hand, it is known as left hand circular polation. So right hand circular polation is clockwise, and right hand circular polation is clockwise and left hand circular polation is anti-clockwise. So if you see here an electromagnetic wave which is having two components, E1, E2, then these two components will have certain phase difference between them. And if you have this relation, that is component X and Y, if they are equal or not equal, but phase difference is 0, then this is linear polation. If Ex and Ey, both the components are equal and there is a phase difference of 90-degree between them, then it is a circular polation. And any combination of Ex and Ey and phase any value other than 0 and 90, it is elliptical polation. So what is the importance of polation? Because if you're a transmitting antenna, suppose you have got a transmitting antenna and receiving antenna. If you want to receive the power maximum from the transmitting antenna, then if your transmitting antenna is, say, right hand circular polation and your receiving antenna is also having right hand circular polation, there will be 0 dB loss. That is, there is no loss because of polarization. Means the antenna which is receiving will give you the maximum power which the transmitting antenna is delivering after radiation. Now, if you have got receiving antenna with left hand circular polation, then you'll get attenuated because of the cross polation. And this cross polation is of the order 25 dB, 30 dB, maybe more also, but that will reduce the power, you can say, by 25 dB, 30 dB, in 1,000 times it will reduce. So it will not receive much signal. It is a very weak signal. Now, if your transmitting antenna is circular polarized, but you are having a linearly polarized antenna, there will be loss of only 3 dB, because only half power of it will be lost because there is another this vector which is matches with some EY, then that will give you only 50% of power will be lost. Similarly, if you are having a vertical transmission, then a vertical transmission will give you 0 dB loss. A circular polation will give you a 3 dB loss, but a horizontal polation will give you cross polation, that is 1,000 times less. But if you have a polation of 45 degree, receiving signal at 45 degree, loss will be only 3 dB from the vertical linear polation or circular polation. So this is very important. This thing will come in my talk further also. Now let us understand electronic warfare. What is electronic warfare? The wisdom of war, which Bhisma advised to Arjun in Mahabharata, it says, if you know the enemy and know yourself in a battle, you will never be in peril. If you are ignorant of the enemy, but you know yourself, your chance of winning or losing is equal. If you are ignorant of both your enemy and yourself, you are certain to, in battle, to be in peril. So that is the warfare where, and it is applicable in all types of warfare. You should know your enemy and you should know your capabilities. So this is what is the wisdom of war, which was given by Krishna to which was given to Bhisma by Bhisma gave this advice to Arjun. Now, what is relevance of EW in present day warfare? Whoever control, there are certain people great people who have given this statement that whoever controls electromagnetic spectrum on battlefield will win the war. This was told by Groshkov, ex-commander of Soviet Navy. Then H. Murer, ex-chief of Joint Staff of USA, he gave a statement, if there is a World War III, the winner will be the side that can best control and manage the electromagnetic spectrum. So the electronic warfare is the management of electromagnetic spectrum. Then Winston Churchill, ex-PM of UK, he told that EW is battle of beams, means you radiate, you capture, you jam, all those things. This is battle of beams. So electromagnetic spectrum is used in modern military, rely heavily on a variety of complex, high technology, electronic offensive and defensive capabilities. Modern weapons and support systems employ radio, radar, infrared, optical, ultraviolet, and laser technologies. In military communication, it is very vital for survival, and this uses electromagnetic spectrum through cable or wireless or fiber. There are various technologies that they go on growing. It goes on like that. Access to electromagnetic spectrum is critical to protect military assets. So you should have capability to access the electromagnetic spectrum around you so that you can control the entire war. Definition of EW, it is said that EW is the battle of control of electromagnetic spectrum. EW is the science of manipulation and control of electronic warfare. EW denies enemy's use of electromagnetic spectrum while protecting one use of electromagnetic spectrum. Means you are denying the enemy that they enter in your electromagnetic spectrum, but at the same time you are protecting your spectrum. EW involves extraction of essential information from the electromagnetic used by enemy, analyze the information to know the capability of enemy, formulate electronic order of battle by assessing nature of threat, restrict enemy's use of electromagnetic spectrum, and protect self's use of electromagnetic spectrum. So this is what is the gist in an electronic warfare. What is the necessity of EW? The ground forces, there are threats of armored vehicles and anti-tank guided missiles. Anti-tank guided missile operates with radar, IR, or ED. EW should protect all these armored vehicles. Naval forces, why it is required? Threat to ship is anti-ship cruise missile, exocet missiles, or different types of missile. EW should break lock of missiles and protect ship. For Air Force, the main threat to aircrafts is missile using radar IR. Missiles can be air or surface launched. Seekers with multiple sensors, that is radar, IR, laser, also has to be protected, and EW should divert the threat. That is also one way of in electronic warfare. This is a picture of just typical airborne EW scenario where you can see their chaff is being launched by these aircrafts. These aircrafts are firing missiles. These aircrafts are firing on the tank. All these things happens in airborne AW. Similarly, in ground-based system, the radar missile scenario, missile is approaching a threat. You have to use certain types of jamming system, that is ECM, which is from the aircraft. You will try to jam the missile or divert it to some other place from the target. Then you have got a naval threat where ship is always exposed from the underwater, from aircraft, from various ships also. So these ships have to be protected. This is the main use of the electronic warfare. Electronic warfare can be classified into communication warfare, radar warfare, electro-optical and infrared warfare, or a hybrid type of thing. In the radar and communication, there are strategic and tactical. Strategic things are done in the peacetime and tactical things are done at the time of actual war. In strategic time, signal intelligence is the most important thing, where you collect the information in communication information and electronic information, that is radar informations. Now, in tactical, you use electronic support measures, electronic attack, and electronic protections. So, electronic warfare, radar EW can be classified into three categories. Electronic support measures, it is also called as electronic support, ES. Electronic countermeasure, ECM, it is also called as electronic attack now. Electronic countermeasure, that is ECCM, this is also called an electronic protection in the modern terminologies. What is an electronic support? Electronic support focuses on the action taken for purpose of real-time threat recognition in support of immediate decisions involving electronic attack. Means it will collect the information in real time and recognize the threat and gives the information to these systems for electronic attack, electronic protection, or weapon avoidance, targeting, or other tactical employment of force. This is for electronic support. It collects the information, gives for the command to decide what action has to be taken. Depending upon the threat identification, different types of action can be initiated to annul that threat or to just collect it. Then electronic attack function includes the use of directed energy weapons, that is lasers, microwave radiation, particle beams, etc., anti-radiation missiles, and electromagnetic pulse, that is nuclear weapons, destruction of electronics to destroy, damage enemy electronic equipment. So in this electronic attack, it can be a soft kill or hard kill also, depending upon what the command decides. In electronic protection, it encompasses the use of such measures as electromagnetic control, electromagnetic hardening, EW frequency deconfliction, and communication. So this is something which has to be, it is known as countermeasure, because if you are attacked by enemy with an electronic attack, then you have to save your things and then either avoid it, or somehow you escape from that, or you have some counter action over that. This is just a block diagram of a typical ESM system, where you have got the very first component is antenna. This is omni antenna, means it receives signals from all the direction over 360 degree. It can be multiple because you have to cover various frequencies. So some of the frequencies we can say 0.5 to 2, 2 to 8, and 8 to 18 gigahertz. Then this frequency is measured and given to pulse format. Pulse descriptive word will be generated. Then this thing will be given to processor. It will go to emitter file, display, and then to console. Depending upon this information, the electronic attack will be taken. Because this omni antenna will not give you the exact direction of signal, then you require a direction finding antenna. Different types of techniques are there, which will give you the exact angle of arrival of the signal, which will be part of your pulse descriptive word, and then you can take the action. Now, I will tell you one very simple thing, what you will understand what is electronic warfare. Suppose you are kept inside a dark room, big hall. Okay. Now, there is somebody who makes a loud noise. What will happen? Your ears will listen to that. You are in dark. You are not seeing from which direction it is coming. Now, some noise has come. Your ears will pick up. So these are omni antennas because it picks signals from any direction. Then your brain will process it, and you will turn your eyes towards that sound. So you are now finding the direction of arrival of that sound. Now, if that sound is fair to you, or if sound is good for you, you will accept it. If it is not good for you, what you will do? You make a louder sound in that same particular direction with the same amount of more amount of power and in the same frequency, so that that sound gets suppressed. So that is electronic attack. So what has been done is, your human system is the best EW system, because your eyes and ears are the sense organs or antenna for your body. So now we come to the electronic warfare antennas. We call it eyes and ears of EW systems. Why electronic warfare antenna? Because they are special in nature. They are tailor-made to meet specific applications. They are not available off the shelf from foreign source meeting specific requirements, because you have to make you have to tailor make it to your requirement, what you want to do. You cannot make a universal type of thing. Then it has got stringent electrical and environmental requirements. So these are some of the very important aspects which has to be taken care in the electronic warfare antennas. Now we come to direction finding antenna. There are different types of direction finding antenna. That is rotary DF, amplitude comparison techniques. I will come one by one on each. Phase comparison interferometry, phase comparison digital bearing discriminator, and time difference of arrival. So there are 4-5 types of technique. One is rotary DF, other is amplitude comparison or phase comparison, and time difference of time comparison. So objective of the EW antenna is signal search and identification. This is the first step which is done in electronic warfare. Then you have to find the direction of arrival, and then you have to take action for countermeasure. So these are the things which are there in electronic warfare. For now, I will discuss the antennas for signal detection and other things. For detection of the signal, because in the war field, you don't know from which direction the signals are there, which direction the electromagnetic radiations are taking place. So you should have a system which is omnipresent, means which can receive signal from all directions over 360 degrees. So that first thing is, you should know what is the signal, what is its frequency, what are the things, and you should be covering the entire 360 degree so that you get the signal identification. There are different types of antennas, that is biconical antenna. All the antenna names are basically based on their shape. So biconical antenna means there are two cones. Conical log spiral antenna means it is in form of cone, but it follows a log spiral. The spiral is in logarithmic form. Then disc cone antenna, it has got a disc and a cone. Blade antenna, it is a very thin antenna, so it is called blade. It looks like blade antenna, and coaxial dipoles, etc. There are various types of antenna. I am discussing a few of them. The biconical antenna, why it is required? Because you don't know the frequency of the incoming signal. So your system should have the capability of detecting any frequency signal. So it should have broad frequency coverage. It should have excellent omnidirectional pattern in azimuth, because it has to take signal from all the 360-degree. It can, polarization can be circular or slant linear, because when the signal is transmitted, its polarization changes because of the Faraday law of rotation. So if you are not suppose you are having a linear polarized vertical polarization, and you are using a horizontal polarized signal, you will not receive the signal unless you make it vertical polarized, but you don't know what is the polarization of the incoming signal. So what is done is, you require either a system to make this circular polarization receiving, so that it can receive the signal, of course 3 dB down, or it should have a slant linear polarization, slant at 45-degree, so that it can receive any sort of polarization. So these type of antennas are useful for all types of platforms. So you can see here, these are two cones with apex at the center, and it is being fed by the cable from this point to this point. So the outer conductor of the cable is connected to the one of the cone, and inner conductor is connected to the other cone. They are separated. It has to be hanged. So some methods are used, like you can put a dielectric type of rods so that it can be make vertical. These are some of the rigid forms which are used to make it make the cone sit over one top of the other, and suitable polarizers are used. Printed circuit polarizer circuits are used, which can rotate the, because this gives you vertical polarization. So either use a circular polarizer or a slant linear polarizer, which are printed circuit methods, and it can make the antenna responsive for all sort of polarization, because it is made slant 45-degree polarization or circular polarization. These are some of the antennas which we have developed, and if you want separately, you can have got these three types of antennas. Then if you are want at a one place only, because you don't have the space to put various antennas, it can be stacked together. This is a conical log spiral antenna. You can say it is a cone. Of course, they are covered with radome. Now, if you see the pattern, this is the azimuth pattern of an omnidirectional antenna. You can see this is a circular. So it can receive signal with same strength over 360-degree. But in elevation, it has got a beam. So this type of antenna are biconical antennas, and they are very useful for signal identification, signal detection. Then we have got a disc cone antenna. This is for communication band, where cone is inverted here down, and there is a disc made, because in low frequency thing, the antenna size becomes very large. So you cannot have that much big metal sheets and all. So it is uh, realized in form of using different types of rods. This is a blade antenna which is mounted on aircraft. You must have seen in various blade antennas mounted on even your civil aircrafts. This is one of the antenna mounted on ship, which is for communication band. Then we come to direction finding techniques. In direction finding techniques, there are mainly, as I told you, different types of direction finding technique: rotary DF, amplitude comparison, phase comparison. In this phase comparison, a baseline interferometer and distal bearing discriminator. Then time difference of arrival. These are the four techniques which are very popular for identifying the direction, knowing the angle of arrival of the signal. After the Omni antennas has given that there is a signal. You have to find out from which angle, which direction it is coming, so that these techniques are used. Now, a rotary DF antenna, it can be rotated manually, and the cursor and read out positions. Suppose you are rotating. Now, when you are rotating, you will find this is the maximum coming. So you can say this is the direction of arrival of the signal. It can be automated also using the centroid algorithm to make that, because any antenna you put, there will be a back lobe. So to avoid that back lobe, we use two antennas. One is omni antenna and other is a rotary antenna. So the signal which are more than the omni antenna will be taken as the signal. If it is less than the omni antenna, it is not taken as signal. So they use logic to accept only signals above a threshold. That is, the omni antenna sets a threshold. Its advantage is high DF accuracy, large range due to high antenna gain, simple processing algorithm. It has disadvantage that it has got low probability of intercept, because when it is rotating, it will intercept the signal only once, but other times, by that time, the signal may disappear also. The probability of intercept of this signal is low, and it is a slow processing system. Then rotary DF antenna, of course, we have seen. You can see some of the rotary DF antenna. This is the omni antenna, which gives the threshold, and this is the rotary DF antenna working from 1 to 18 gigahertz, and this is the rotary DF antenna working from 18 to 40 gigahertz. So DLRL, we have developed these type of antennas, and they are being used by our services. This is one antenna which has got one other technique, that is a sum and difference technique, where the sum and portion means these two antennas are gain and phase mesh antennas, and if their output is sum, you get a beam like this, which will give you a course direction, and the dip, if you add 180-degree phase out of these two antennas, it will give you a null, which will give you the exact direction of arrival of the signal. This antenna, it is a rotary DF and cylindrical parabolic reflector with a feed. It will give you a fan beam antenna. In the elevation plane, the beam will be broad because it can cover broader angle, but in the azimuth plane, the beam will be very narrow, of the order of 1 degree, 2 degree, like that. So this narrow beam, when it rotates, it will intercept the signal very accurately within that. Then we have amplitude comparison antenna, where we can use, at least for understanding concept, we use two antennas, which can be, which pattern when it is compared, if you see here, this antenna, suppose this antenna and this antenna you're considering, these two antennas patterns are like this, and their intersection will give you the direction of arrival. So if you have the antenna, the angle of arrival is determined by determining the ratio of signal received. So depending on if this is ratio of this amplitude received will give you the angle of arrival, and accuracy depends upon amplitude imbalance. So in calibration is done and inversely proportional to error slope. Advantage is it is broadband coverage and simple processing. It has got an antenna, a detector, a log video amplifier, and differential amplifier, which will compare these two signals and give you angle of arrival. If you have 4 antenna system, you can see each antenna will cover 90 degree. So 4 antennas can cover 360 degree. And these are the receivers. The signals are compared. This gives you sine component. This gives you cos component. And the interaction of this will give you the tan component. So these are benefits of this system is wide open in time, space, and frequency. DF accuracy is of the order of 5 to 7 degree. It is widely used on all platforms. Tactical applications are very effective. Its drawback is amplitude matching in RF chain is important. It's complex and costly because 4 antennas, 4 receivers are there, but they are instantaneous. But if you want to increase the accuracy, you can have 6 antennas, 8 antennas, depending upon how much accuracy you want. Types of antennas which are used for these techniques are equiangular spiral, Archimedean spiral, 2-arm, 4-arm spiral, different types of antennas out there. Then you have got log periodic antennas, which are coplanar log periodic antenna, pyramidal log periodic antenna, horn antenna, and sectoral horn antenna or pyramidal horn antenna. Then you have got slot line radiators. So why we need frequency independent antenna? Because the frequency independent antenna can be realized if the antenna shape is specified entirely by angle. If you define the shape of the antenna by angle, it becomes frequency independent. If the antenna shape fit into truncation principle, it will also be a frequency independent antenna. And if negligible variation in pattern within the period will be observed in this. So some of the examples of antenna are equiangular spiral and its variants, Archimedean spiral, log periodic antennas. These are equiangular spiral. You can see here there are two 4-arm spiral. There are 4 arms following this equation. Rho1 is rho naught e to the power a5, where rho naught is the constant, a is the variation, and phi is the phase difference between the two. So this is unlimited frequency band, depends upon the physical realization of the antenna. It gives you circular polarization because of its geometry. It gives you low acceleration over wide angle. It can be flush mounted with the structure, and it gives you a control over the desired pattern. You can see here, these are the measured pattern of this type of antenna. It gives you a coverage of about 90 degree, so that by 4 antennas you can get the direction of arrival. Then we have got conical log spiral. It gives you a hemispherical coverage, where you can see this is the spiral which follows the log equation, and it gives you hemispherical coverage. Azimuth is omnidirectional, and it has got the hemispherical coverage over the beam. These are the antennas which are used either on top of the ship or at the belly of the aircraft, so that you can detect all the signals from the ground. These are widely used for tactical applications. Then you have got another type of antenna, that is Archimedean spiral antenna. It gives you circular polarization. It can be flush mounted. They are very lightweight. Photolithographic techniques are used to, and the antenna is defined by only angle, that is theta. A and B are constant. R will depend upon this. So the R will be dependent on theta, that is the angle. So it becomes frequency independent. So you can see here, these are the various components which are used to realize this antenna. Then these antennas, like 4 antenna DF, it has been used in a helicopter. You can see these are the measured patterns of the antenna put on the helicopter. Then we have got 6 antenna DF. You can see there are 6 antennas, which gives you 60 degree beam width. It covers the 360 degree. It is mounted on the aircraft. Then another frequency independent antenna is a log periodic antenna. This log periodic antenna is its linear dimensions scales with frequency, that is length, the ratio of this length, distance from the apex, and distance between the two elements. That is, they all follow a constant ratio of tau. Tau is a repeatable dimension. So the antenna characteristics repeats the logarithm of frequency. So if you take the pattern of the antenna will change with the logarithm of frequency. As the frequency changes with log, the antenna pattern will also change. These are fabricated in different ways. These are some of the printed circuit spiral, cavity backed spiral antenna. These are some of the log periodic antenna. This is printed circuit. This is chemical milling. This is dual polarized is log periodic antenna. These type of antennas are being used. This is for shipborne system. This is on the this is on the submarine system. These are radomes which are made here. They have passed 60 bar pressure and they are being used by our Navy. These are some of the shipborne systems. This is one of the very prestigious uh, antenna system. This gives you the omni coverage, that is identification of the system, and these are 8 antenna direction amplitude compression DF system. These are mounted on uh, various platforms. Now, the phase compression DF is if you place 2 antennas at a distance d, the signal arriving from that any point, this antenna will receive first, and this antenna will receive after certain time or certain distance. So this is d sine theta. So the phase delay which will be between this point and this point will be 2 pi d sine theta by lambda. So theta can be defined as angle of arrival, that is sine inverse of psi lambda upon 2 pi d. Now psi is known because you measure the phase difference between this antenna and this antenna. Then lambda is known because frequency is known, and d is the also known, that is the distance between the 2 antennas. So this gives you the method to compare the phase of the 2 antennas, and then you can tell the direction of arrival. So if the to avoid, because these antennas has to be within lambda by 2, less than lambda by 2, distance cannot be more than lambda by 2 because after that the ambiguities will come. So ambiguities can be resolved. So if you have to measure the frequency at the highest frequency, you should have a distance between less than 1.5 centimeter, that is at 18 gigahertz. So this is how it is phase is compared, and by comparing the phase you get the thing. But many times it is not possible to place 2 antennas side by side within this distance. So a different type of uh, techniques are used. You can use 3 or 4 antennas. With 2 antennas will be very close, less than lambda by 2, which will give you this thing. Other antennas will resolve the ambiguities. So the algorithm is used is Chinese remainder theorem. Here, this is how the antennas are placed. This one array covers 90 degree of sector. So if you put 4 arrays, it will cover 360 degree. They are very wide open in time, space, and frequency, and its accuracy of direction finding is less than 1 or 2 degree. The drawbacks are its phase matching in RF chain is very difficult. Amplitude compression DF for ambiguity resolving is required. Frequency information is needed here because it doesn't give you frequency information. It is complex and costly because various channels are being used here. Then another phase comparison technique is that distal bearing discriminator. You have a circular array, and this circular array will generate phase depending upon the arrival of the signal. Each antenna will give you certain phase, and different modes of the phase are compared, and that comparison will give you the direction of arrival. Then time difference of arrival, because if you got 2 antennas separated by a distance, then and you are able to measure the time of arrival. That suppose this antenna and this antenna, if you see, the signal which is arriving here, it will arrive first here, and after certain time t, it will arrive here. So if you measure the 2 time arrival of the 2 antennas, the difference between the 2 you can know, because this is d cos theta. So time of arrival will be d cos theta by c. C is the velocity of light. So you are only one component, that is t. The time has to be measured because distance is known, theta you can calculate, and c is the velocity of light. So this system is very accurate. Measurement of time difference is very accurate. length of baseline. So ambiguity exists because of omnidirectional antennas are used here. So the baseline, for an example, if you're using a time measuring clock of 100 megahertz, that is 0.01 microsecond, you can measure about 1 degree or 0.02 radian, and for that your baseline will be 150 meters. So you have to put your antennas 150 meters apart. But if you have a clock of 1 gigahertz, your baseline will be only 15 meters. So this is where your accuracy of time measurement will give you, in a shorter baseline, you will be able to get better accuracy. The advantage of this system is independent of frequency, because frequency term is not coming here, immune to multipath, simple processing. Disadvantage is CW signals and DF not possible. Large baseline and high clock signals are required. These are the antennas which have been used for time difference of arrival technique. These are omni antennas, and they are having polarizer, that is slant linear polarization, and they are all amplitude matched. These antennas which are developed have been used on vehicle. You can see here, this is the 18 to 40 gigahertz antenna. This is 0.5 to rho TDF antenna, 0.5 to 18. This is your omnidirectional antennas, biconical antennas. These are phase comparison DF, digital bearing discriminator antennas. All these things are there on the platform. Now, once the direction of arrival is received, then you have to analyzing it, then you have to jam the signal if it is required. Now, the first generation of jammers were horn. Jamming is you generate high power beams. So high power beams can be generated, either you have a high power generator or you have got a high gain antenna. In the first generation, there were horns which were being used, but it has got its limitation. The horns which are being used, it has got its own limitation. You can see here different types of horn. These are the first generation jammer where horns are used. Now, if you want to increase the ERP, that is the power of the radiation power, either you increase the power generator, use a generator with high power, or you increase the gain of the antenna. Now, gain of the antenna will depend upon the aperture of the antenna. Now, the antenna aperture, if it is increased, your antenna gain will increase. So we come to the second generation of jammer, those are reflector antennas. Reflector antennas are basically a paraboloid. Here, the property of paraboloid is incident rays from focus to the reflector are parallel to beam axis after reflection. They are parallel. Path length to the plane perpendicular to the axis are constant. This path length from here to here or here to here is same. Thus, a spherical wave is transformed into a plane wave. So this is how these spherical parabolic antennas are used. Now, the reflector antennas is designed by F by D ratio, the focus to diameter ratio. Now, if you have low F by D, the reflector will be deep, more subtended angle, but less aperture blockage, because your feed antenna will be having less aperture, so it will not block the reflection from the reflector. But if you have high F by D, the reflector will be shallow, but less subtended angle, and hence more aperture blockage will be there. So the feed support also blocks the reflector radiation. It increases side lobe, reduces gain, because you can see here, this feed is being held by certain external parts. Sorry. Okay. So these things can be avoided. If you see here, if you put the feed not in the center of the reflector, if you offset the feed, then also you can get this type of where your side lobe will get reduced. This is a fan beam millimeter wave offset reflector. You can see here, this is the fan beam in the elevation, and this is in the azimuth plane, which is a narrow beam. And its side lobe has gone about 30 dB down. Then in order to increase the gain of the antenna, one can use Cassegrain reflector antenna. Now these reflector antenna which I am talking about, they are all being used for satellite navigation in the ground control systems. So the focus of the paraboloid lies on the, so here in a Cassegrain reflector, you have got two reflectors, a parabolic reflector and a hyperbolic reflector. And the feed is kept at the apex of the parabolic reflector. So your feed is not projecting out, so that blockage will not be there. And this feed radiates towards the hyperbolic reflector, and from this it is reflected back to the parabolic reflector, which makes the collimated beam. A large subreflector again will have short axial length, that is, this is the axial length, but large blockage. But if a small subreflector is there, more axial length and less blockage. So I will not go into the design of it. It is there in the published literature. So advantage of this reflector is feed is near the apex of main reflector, so it has got less plumbing loss. The feed is here, you can see here, this is the here. Now this has got less plumbing loss because you don't have to run the feed line or transmission line from this point to this point. So it is here only. Reduces spillover and minor lobes, hence low noise. Efficiency has 10% increase from the front fed reflector. It has got low cross pollination and high gain. Now, if this type of reflectors are used for jamming, it has got a beam. Now, if the target is moving, then in that case, what happens? The beam, if you are pointing towards the target has moved. So you are still there. So your jamming effectiveness has gone. So we have introduced the concept of auto track horns. There are 4 horns, 2 in the elevation plane and 2 in the azimuth plane, so that it gives a crossover over the main beam. So if the target has moved out from here, then there will be error signals generated. These are in receiving mode. So these horns will receive the signal and it will generate an error that the target has moved somewhere. So that error is, when it is corrected, it will move the main beam, which is at the center of that, it will move the main beam towards the target. This type of jammer system, this is for millimeter wave jammer. This type of system has been mounted on chips. You can see here, this is the antenna. These are the antennas put here. These are the antennas for the ground-based system. Now, as we said, that either we increase the aperture or increase the input power. But there are certain techniques for increasing the power and also with less amount of power generation, means generators. So in that case, what is done is you can use array and certain types of feed network and phase shifter, so that you can change the beam position from one place to other, and the combination of the array radiation. There are number of elements here, and each element is fed with a small power amplifiers. Now, instead of having very high power amplifier which can damage the antenna input, you use small power amplifiers, a large number of them, and large number of antenna elements in array form. So the power radiated by each antenna is combined in space, and it forms a very large power, high ERP of the antenna. So one of the systems which is now being used by us is a lens-fed multiple beam array. A lens-fed, so we can just see how the array and reflector, they are different. In array, you use multiple radiating elements, better aperture control. You have got high noise interference because number of elements are there, more complex, and its cost will be high. Whereas reflector, it is a single radiator, one aperture distribution. You cannot change the distribution. Whereas in array, you can change the aperture distribution depending upon your requirement. It gives you low noise performance. Construction is simple, and it is good compromise between performance and cost. So there are various types of beam forming networks. There, like you can see blast matrix, other things. So I will be more emphasizing on the Rotman lens, which is the latest technology, and we are the 5th country in the world who has got this technology. Now, why we required this technology was that, you know, a ship is a very price target in war. Thousands of crores are there on the ship in cost of the ship. So, and the ship is in the sea, it has to handle multiple threats. So your system should have multiple threat handling capability. It should radiate very high effective radiated power. It should have short reaction time, which is very fast, so that you can point your beam very quickly. It should cover broad frequency band, because EW frequency band is very important, and it should have wider angular coverage. Now, if you see a ship, it can be attacked by a ship, it can be attacked by a helicopter or hostile ship or fighter aircraft. If you launch 4 missiles simultaneously on a ship, any one of them can hit, maybe. So ship cost you thousands and thousands of crore, whereas missile cost you some few thousand crore, 1 or 2,000 crore. So we have developed a system which is known as lens-fed multiple beam array, which generates multiple beams over 360-degree around the ship, so that it can handle multiple missiles or multiple threats from over 360-degree over the horizon. So this lens-fed multi-beam array system is electronically steered beams. So low reaction time, because the beams are steered electronically, reaction time is microsecond. High ERP through spatial power combination, and switchable against multiple threads. It can handle multiple threads by switching. So this is the Rotman lens, which is a phasing device, and these are the TWTs which are behind each of the element array. So these TWTs are not very high power, they are small power, low power TWTs, but when they combine in array, they generate high ERP. Here is a switching system, switching matrix, which switches the beam. Now, if you switch the beam to this point, your beam will be in this direction. If you switch the beam to this point, your beam will be in this direction. If you switch the beam in the center, so depending upon your selection of the port, you will get the beams. So these are the measured radiation pattern of the beams. There are 15 beams over 90 degree. It covers 90 degree. So if you have 4 such things, you have got 60 beams to cover 360 degree, and you can handle multiple threads together. I will not go into this design of it. These are the hardware. This is the Rotman lens, and these are the radiating elements which have been arranged in a linear array, and it is fed through Rotman lens. These things have been patented. This patent lies with us. These are the field trials when we were doing this multiple beam array. Now we come to GNS. What is GNSS? Global Navigation Satellite System. The goal of the Global Navigation Satellite System is real-time navigation, that is, measure the user position and velocity in real time. It can be done anywhere on the earth, under any weather conditions, and precise timing, that is clock synchronization, is the goal. So there are 3 component segments in a satellite navigation system. One is space segment, which is the satellite. This is the space segment. Other is control segment, which is the ground stations, which controls the satellite, which gives the corrections. positions, everything to the satellite, and the satellite retransmits it to the ground for the user segment, where the users, they use the way we use the GPS. So that is, we know only the user segment, but not much about control segment and space segment. A space segment has got 24 satellites. This is one of the GPS satellite I'm talking about. It has got 4 satellites in 6 orbit planes inclined at 55 degree. It is located at 20,200 kilometers above the Earth. It has 12 hourly orbits, that is in view of for 4 to 5 hours each, designed to last 7.5 years. Different classifications of their block 1, 2, 2A, 3R, like that it is there. Then in control segment, the master control station is responsible for collecting tracking data from the monitoring stations and calculating satellite orbits and clock parameters. This is the control segment, what it does. It is the master control station. Then you have got monitoring stations. The monitoring stations is responsible for measuring pseudo range data. This orbital tracking network is used to determine the broadcast ephemeris and satellite clock modeling. It is ground control stations and responsible for upload of information to the satellite. They are located at various places over the Earth. The user segment is most visible segment. GPS receivers are found in many locations and applications. So, just in simple language, what is GNSS antenna? Global Navigation Satellite System antennas are designed to receive signals from satellite constellations like GPS, GLONASS, BeiDou, Galileo, of course, our Indian IRNSS. They are designed to capture these weak signals from satellite that are used for position, navigation, timing, that is for PNT application. The signals which are transmitted from the satellite, they become very weak when they reach the ground. Once the satellite signals are captured by a GNSS antenna, they are filtered to remove unwanted noise and then amplified to reach a signal level that can be processed by a receiver. The receiver uses the timing data from these signals to calculate the distance to each satellite. By combining data from at least 4 satellites, the receiver can determine the user's precise position using a method called trilateration. So there are 2 different types of antennas are very commonly used. One is active GNSS antenna and passive GNSS antenna. You can see here the block diagram. The active GNSS antenna are equipped with an integrated low noise amplifier that amplifies weak satellite signal before they reach the receiver. So the signals are amplified. By enhancing signal quality, active antennas improve reliability, accuracy. These antennas can also compensate for signal loss due to long cable runs. So active GNSS antennas used in fixed installations, high accuracy applications. Whereas passive GNSS antennas, in contrast, passive GNSS antennas do not incorporate any amplification. Instead, they directly transmit satellite signals to the receiver. Passive antennas are best utilized in environments reception, such as open fields or rural areas with minimal interference. Because whatever you get in handheld GPS, they are all the passive antennas, but they are later on given with the low noise amplifier. Such antennas are lightweight and compact form factor, making them ideal for handheld devices and applications where low power consumption is priority. Now, space, the GNSS antenna, the defining factor of that is its frequency range of operation, because it works on L1, L2, L2. It is in L band mostly. There are certain types of antennas that are often used for GNSS application due to specific properties. Space segment antennas. The satellite in space is a unique platform. The environment and the application of the platform requires antenna designers to interact with several disciplines, including mechanics, structural analysis, thermal analysis, surface charging, and radiation effects. Apart from these, the antenna should have high gain, required polarization, and controlled radiation pattern to cover the maximum area on the Earth. So this is what is required from the satellite. That is the space segment antenna. A control segment antenna is, of course, part since it provides the means of transmitting signal to the satellite and or collecting the signal transmitted by the satellite. Not only it should provide necessary high gain to allow proper transmission and reception, but it must also have radiation characteristics which discriminate against unwanted signals and minimize interference into other satellites or terrestrial systems. The operational parameters dictate the necessary electromagnetic, structural, environmental, and specification of the antenna. This control segment discussed in the form of the reflector antennas. In user segment antennas, there are different types of receiver antenna. This covers limitation is imposed to avoid severe multipath because there will be multiple reflections from the various structures. So severe multipath, tropospheric effects. Also, hemispherical beam can remove the need for a tracking mechanism for the antenna. So if you have a wide beam antenna, it can receive signals from 4 satellites. The antenna should be blind to all signals arriving from outside the coverage range. That is, pattern cutoff must be sharp with the no backlobes. So one of the antenna which is very much used in satellite vehicles, they are helical antenna. Helical antenna is nothing but a suitable for omnidirectional requirements. These are the single helical antenna as the general form of the antenna. A finite length helix, mainly in 2 modes. It generates 2 modes, axial mode and normal mode. Axial mode gives you a beam, directional beam, whereas a normal mode gives you a omnidirectional beam. There the design is different. So I will just give you a reference of these antenna. It is there in the text. The helical antenna can be made in the quadrilateral helix antenna. Now here in the satellite navigation, the world accepted concept is that all the signals will be right hand circularly polarized, because the signals which are traveling from ground to satellite or satellite to the ground, they get affected by Faraday law of rotation, where this polarization of this signal gets rotated. So if you're transmitting a linear signal, it may be received, suppose you are translating a vertical polarization signal, by Faraday's law of rotation, the signal will be rotated in such a way that when you receive, it becomes horizontally polarized. So your signal will be 1,000 times less. So a universal concept has been adopted that it should be all antennas, all the signals will be right-hand circularly polarized. So this is quadrilateral helix antenna, which has got 4 elements, which has got, because these 4 elements which are there, the difference of 90° each, because you have to have a circular polarization. So circular polarization can be achieved either, as we learned earlier, that you should have 2 components of equal amplitude and 90° phase. So if you have 4 elements, each is given a phase difference of 90°, that is 0°, 90°, 180°, and 270° relative phase between them, then it will generate a circular polarization. Many times a single helix will work for 1 frequency. So if you require more than 1 frequency, it can be either enclosed type or piggyback type, one top of the other. So it can cover L1 and L2 frequency, 2 frequencies together. Now the satellite, usually when it is looking on the Earth, if you see this pattern, the Earth is spherical. So the power which is there, which is received here, if it is 0 dB, here it will be about 2 dB down. So same power here, then what will happen? This point will receive, this angle will receive maximum signal, where this point will not receive proper signal. But you require that you have to illuminate the earth with an equal amplitude signal. So it is observed that it makes 28 degree between these two angles, so that it covers the sphere of the earth. So a dimple or a dip is required at the center by 2 dB, and this antenna, this type of characteristic of the radiation pattern is generated from the satellite antennas. Now, in one of the example of that is helix antennas are used. There are, you can see here, there are different types of 12 helix antennas, 4 in the center and 8 in the outer circle. Now, these two antennas, the inner element are fed in phase with 90 degree, 90% of power. These are in phase with 90% of power, whereas the outer 8 elements are fed 10% with 180 degree out of phase. So this combination of this will generate a radiation pattern of like this, a dimple in this thing. Because these are helix antenna, it will have right hand circle polarization. So this type of system is used from satellite vehicle to cover the earth. You can generate, for receiving purpose, you can generate circular polarization by cross dipole. The dipoles are linear polarized antennas, but if you have a cross dipole and you make a phase difference of 90 degree between two dipoles, you will be able to generate circular polarization. So to avoid back radiation and other direction, a cross dipole, this is known as cross dipole, which is covered with a backing with a what you say, then I have told you that reflector antennas, which are very important for the ground-based systems, so that this type of reflector antennas are used. Now, in various handsets, microstrip patch antennas are very common, and even in electronic warfare also, microstrip patch antennas are also there. These type of antennas can generate circular polarization. There are these different techniques. Either you have got single feed and you add some 90 degree phase between the two feed, so you get one component here, and you are adding a 90 degree phase between them. It can generate circular polarization. Here also a single feed, but you are given a lambda by 8 phase difference between the two, so it will give you 90 degree phase, so you get circular polarization. A single feed, you can have a nearly square patch, which is a corner, so you can get two components. Again, it will give you circular. There are various techniques of generating the circular polarization for a microstrip patch antenna. Then, if you want to use for multiple frequencies, say L1, L2, L5, so in that case, you can have multiple patches being fed by different methods. Like if there are 4 feed points here, if you see here, A, B, C, D, each of them, they have got phase difference of 90 degree. This is 0 degree, then this is 90, this is 180, this is 270. So a combination of this will give you a circular polarization. If you want cover more than 2 frequencies, this is L1 and L2, you can have got 2 patches and one up top of the other, and these are the practical available antennas which are used for receiving L1 and L2 frequencies. Then you can have array antennas, because you can get, like, you have a set of 1, 2, 3, 4. This is for L1 frequency, and 1, 2 for L2 frequency. In the same array, you get 2 frequencies covered, and each are circular patch with a phase difference of 0, 90, 270, 180, 270, like that. So this phase difference, when it is given, it covers the 2 frequency, L1 and L2, and they gives you the array effect also. So its gain will be low. large. Now, a very big problem with the antennas are in satellite receiving antennas are choke ring antennas. What is choke ring? Choke ring is nothing but a concentric metal ring structure, which is also called as corrugation, around a small aperture antenna. This is the main antenna. Now, in order to avoid that the reflections take place from, you can say, from the multipath, only direct signal should reach here. So metal corrugations are generated, which has got depth of λ/4 and λ/2. So this gives you a capacitive high impedance, which chokes the propagation of waves from which is going towards this antenna. So that's why it is known as choke ring. It chokes the radiation because of the capacitive high impedance which it is providing. So this is known as choke ring antenna. Then a choke ring can be that is in the this is in the vertical plane. So this is vertical plane choke rings. There are various rings, and these are the absorbers which are put below the antenna, and these are the metal plates, and these are the absorbers which are put. So all the signals which are coming from the ground reflection will be absorbed by the absorber and will not reach the antenna. So I will just, Dr. Rane, can I continue for 5 minutes?
Yes, we can continue for 5 minutes.
Just 5 minutes, because a lot of things are left. I will go a bit fast. Already I have given you the this thing. Okay. So radome, as I told you, it is a dome for the antenna which gives protection from the environment to the antenna. It is transparent to electromagnetic waves. They are broadband because it to cover all the entire frequency band. It should have low loss of the radiation, high strength, suitable for all types of platforms, and withstand environmental hazards. There are different types of radome technologies. Some of them are solid wall, two-ply, sandwich. This is solid wall, means a single thin wall or half-wave radome, a single material, single dielectric material. These are made of, radomes are made of dielectric material basically. This is a sandwich where you have got low dielectric material in between and high dielectric material at the outer surfaces. Then B sandwich, where you have got high dielectric material, constant material in the middle, and the edges are the low dielectric materials. It can be in different shape and way. A sandwich, B sandwich means you can have various different types of layers. B sandwich, multi-layer configuration. There are different ways of making this type of radome. These are some of the radomes. These are this pod radome. These are all shaped radomes for the aircraft. These are submarine radomes. These are for vehicle mounted radomes. All these things are there depending upon the various types of requirement and the system. The trends in antenna technology is that it requires multifunction, because one antenna will do one function. Now it is required that from the same aperture you do multifunction, multi-frequency, wide frequency bandwidth. A modular approach is also there. It should be conformal to the extent it is possible. It should be agile, low transmission loss, and desired radiation pattern can be generated from them. Printed circuit antennas are very popular because of its low profile, easy to fabricate, and low cost. Because you can see here, this is a metal patch which is being fed by metal feed line, and these are the dielectric. Ground plane is metal. So this is how the patch antennas are generated. These are some of the patch antennas which are designed and developed by DLRL. These are the printed circuit dipole antennas, and a combination of this will it gives you 16 beams over 360 degree. So this gives you beam switching array. You can, in communication, you can switch on one beam and communicate. Other sides you are not open, so you will not be able to jam. This is one method of achieving printer circuit antenna for polarizer agility. This is what I talked to you about the linear multi-beam phased array. This is the three-dimensional Rotman lens-fed multi-beam planar array. It can generate beams in azimuth as well as in elevation. Then photonic systems of antennas are there. Photonics are used. Distribution of RF signal via optical fiber, because the normal electromagnetic cables, they are very, you can say, lossy. So to avoid those loss, optical fibers are used, which are low transmission loss over long distances, lightweight, small size, broad bandwidth, immunity from electromagnetic interference and crosstalk, low observability, suitable for beam steering and signal processing. So you can see here, this is how the RF which is generated. It is transferred to the laser. From there, it is converted into optical range, and this is given to true time delay unit, and further it is given to phase control unit and then array. So this photonic base, this loss from this end to this end is reduced because of the fiber optic technology. Then we have reconfigurable antennas. The same antenna aperture to serve multiple functions. Physical structure of the antenna change in real time. Many small antennas configured in an array. Proper amplitude and phase excitation required. Photonically activated RF switches are required, and active and passive methods to physically and electronically configure antenna arrays. Now you can see here, this is one of the MEMS actuated based reconfigurable antenna. The position of the metal, this thing can be changed by which are there. These actuators will change the position and it will change the direction of the beam, size of the beam width also. So these are MEMS based actuator based reconfigurable antennas. Then shared aperture. From the same aperture, you can generate multiple purposes can be served. That you have got UHF antenna, then you have got IFF antenna, then ballistic tank also there, S40 antenna, different types of, you can generate beams and antenna. These are combining the various types of requirement, multifunction. Then fractal antennas are one of the field where people are using it, and it requires that it is recursively generated self-similar structure with fractional dimension. Suppose you consider here, this is one patch, this is another number of small patch, but it is a bigger patch. This works for other frequency. Then these are the set of the patches which works for other frequency, but these patches are repeatable. So these are multi-band frequency operation, low profile and reduced size. Wireless applications are very much in use. It is being used in UAV, and it is also known as a smart skin. The plasma antenna, plasma is the fourth state of matter. Plasmas are conductive assemblies of charged and neutral particles and fields that affects. Plasma antenna performance is equal to metal antenna, but is lighter. You can see here the advantage, it is stealth, is probability for remote deployment, much more compact and lightweight, greater efficiency. It is applicable for military applications where stealth and EW are primarily concerned. Ground penetration radar, high speed data communication. Now you can see here, this is a plasma antenna. When the plasma is, it becomes a reflector, and this is the feed. When plasma is removed, it becomes transparent. Similarly here, this is the plasma reflector. When plasma is generated, it becomes a reflector. It reflects the signal, and then if it is switched off, it becomes transparent. So smart antenna technology is also latest technology that antenna with built-in multifunction capabilities and processing are often called smart antenna. Antenna is never smart. The system which is incorporated into that, they makes it smart. If they are conformal as well as they are known as smart skins, its function includes self-calibrating, adjust for changes in the physical environment, that is temperature and all, self-diagnostics. Test can run continuously or run periodically. If problems are diagnosed, action include limit operation or shut down the system, adapt to new condition when processing or reconfiguring. So in the conclusion, we can see that antenna performance affects the accuracy and effectiveness of EW and SatNav systems. Antenna characteristics like wide frequency bandwidth, high gain, shape radiation pattern, all and cost effectiveness are required for EW and SatNav antennas. Various techniques to achieve improved performance have been discussed. A large variety of advanced antenna systems and redomes designed and developed is presented. Now the requirement is continuous research for more efficient, smaller size, lightweight, cost-effective alternative to the existing ones is always there. So with this, I conclude my talk. If you have any question, you can ask me.
Yeah, participants, if you have any questions, please unmute yourself and you can ask the questions. The forum is open for question answering now.
Good evening, sir.
Yeah,
Good
sir, I
evening.
can see one question in the chat box from Ms. Komal. What is nano antenna and how it is different from other antennas? And please share its applications.
Okay. Nano antenna is what I was talking about, the advancement in antenna technology. Nano antenna is the size of the antenna is get to be reduced. But if you reduce the size of the antenna, certain things like gain is what you can say, it's power handling capability, all these things. But the nano antennas, which are now technologies are being talked about, their materials are being explored so that the antenna size can be reduced and gives this near to same performance which a physically available antenna is giving.
Hello, sir. May I ask one question?
Yeah, please.
Yeah, go ahead, sir.
Sir, in submarines which are immersed in the water very deeply, so what kind of antenna they are using?
Okay. As I told you, some electromagnetic radiation cannot travel in water. So the submarine antenna which are there, they are mounted on the submarine, but the submarine, when it pops up, it quickly analyzes, gets the information of the electromagnetic environment, and then decides what action has to be taken. So no electromagnetic signal travels in water. There are sound waves which are there inside the water. So the antennas which I have discussed about the submarine, they are put under radome which can bear lot of pressure, at least 65 bar pressure I know which is there. And the submarines will use electronic systems when it comes out, pops out of the water. Okay.
Thank you, sir. Thank you very much.
Thank you, sir. There is one more question in the chat box, and that is, can I use antenna in terahertz range?
Yes, terahertz range antennas are there. Terahertz antennas are there.
One more question, like beginner in research for antenna design, how to done effectively? So I think we should not take this right now.
I could not
Please,
get
one more. Are the multi-beam antennas that now in use with 5G technology and the multi-beam antenna system for jamming are same?
Yes, it is being used by our Indian Navy also.
Okay. Any further questions from the participants? I think it's done. Okay.
Okay, it is quite
So,
late also.
yeah. So, Dr. Ashwini, thank you so much. I would like to express my sincere gratitude for delivering an insightful session on this interesting topic. I appreciate your energy and stamina at this time because it's 9:20 around, and I read your requirements as well in the last slide that the research should going on. So it
Yes.
should, yeah. So that should be taken up by all the participants. Yeah. So thank you so much, sir, for your invaluable contribution, and we look forward to future opportunities to learn from you. Such a thing. Thank you so much.
I must for giving me this opportunity. After, though I'm still interested and working in the field of antenna, so I keep myself very much try to be updated. Of course, I cannot.
Yes.
I am not able to spend much time, but yes, I am also associated with these various people in this field. So thank
Yeah.
you to all the participants for bearing me for so long on such very lucrative topic. But I hope I have conveyed certain insight into this field. Thank you, and thank you very much to all of you.
Yes, sir. Thank you so much. You can take a leave from the meeting. Yeah. Participants, there is an announcement for you. I have posted the attendance and feedback links in the chat box. Please fill it, and then you can take a leave from the meeting. Thank you. Thank you so much. Good night, all of you.
Good night. Thank you, sir.
Good night.